Okay. Hi, everybody. Glad you're here. So today I want to discuss this topic of the cycles and how the cycles are related to the power law. So today we had a very nice Bitcoin first discussion that basically featured. I had read. It featured one of my collaborator and friends. We are working together as a group in understanding Bitcoin power law, but we have our own differences among different of us. We have different approaches. My understanding of the power law is based on my 12 years of working with the power laws, finding power laws in Bitcoin. So I don't want to say I have, like the ultimate authority, because there is no authority in these kind of things. It's all about understanding. It's all about studying, going in the depth of the data and so on. I'm sharing actually the wrong thing. Let me share something else. Okay, I want to share this. Okay, and actually we can look at the same graph we were looking before. All right, I think now we are it. All right. So we can have our own differences, and it's nice because that give us opportunity to explore different things. The only problem I have, so I don't know if you didn't participate to Bitcoin first, it's these events. I don't know I think they happen pretty regularly. I'm not sure every day, but they are held by Dr. Kruger. He's a very liked Bitcoiner and analyst, and so he is also he organizes this conference. Last time we had a conference in Las Vegas. It's called Bitcoin First, but they also have an X account, and they also have these regular spaces where until now we have been basically just covering a particular topic. Everybody was discussing or saying their opinion. We are trying to do them a little bit more focused, where they have like some guest person coming in, discussing a particular topic, and then people can join and ask questions or make comments and so on. And today they interviewed or they discussed things with Plan C. Right? As I say, if you see me say anything against his positions, is most from an intellectual point of view. People that you know very well, I talk about in a more aggressive way when I think actually we are a bad actor, like I think Plan B, for example, is. But we are going briefly to talk about S2F today, but on as a side issue. They also discuss today S2F, the other model, stock to flow. But it was mostly about Plan C idea that maybe the cycles are being broken for this time. We are supposed to see a new cycle, right? We had one that peaked about 4 years ago, 3 years ago, and the discussion is we are going to have another cycle soon. And in particular, what is the relationship in general between the power law and the cycles? And Plan B, it did a good job in describing what the power law is and where the cycle came in. But we have strong disagreement on this topic. So I will explain you what his positions are and what are my positions. His positions is that is the part where I was disappointed, because everything we do, what I'm trying to show people, and again, it's not that Plan C is a student of mine, and so I'm disappointed about that. I did introduce him to the power law. He didn't know anything about the power law, and we came together and I gave him a bunch of presentation. One time, in fact, we talked something like, I don't remember, it was like 6 hours, 7 hours, 8 hours together, something like that. We were going through many different things. He told me about his experiences with crypto, etc. And I introduced him to the topic. But he's doing his own work and is exploring. What he's probably very good at is he has very good intuition. I told him many times he has no formal education in mathematics or physics, but he has a very, very good intuition in what patterns. He's very good at pattern recognizer, and today we have tools, a lot of tools, like for example ChatGPT, that allows us to test some of our ideas. This is great because actually I invite everybody to be like Plan C. You don't need to have a math degree to actually explore these things. You can interact with ChatGPT, ask him to do certain things, pick up certain terminology, because this is exactly what Plan C is doing, is learning new topics, new ideas, and then testing them with his intuition to try to understand different aspects of Bitcoin. This is great. Everybody should do that, because in this way, everybody becomes like what is called scientist citizens, right? Everybody should be. We live in an era where we have so many tools where we can learn about the media, right? Like Elon Musk was saying, you are the media today, right? We can become journalists in a sense, or we should do some of the work that journalists do. Now, some people, unfortunately, they say, I did my research, and then they go to stupid websites that have a lot of misinformation. We are not able to compare, because you should always compare sources. With mathematics, is a little bit easier because it's no matter of opinions. There are no different sources say, hey, it is like this with this particular function or with this particular concept. Oh, it's exactly the opposite. Like with other topic, the only way to know if you're dealing with something that is fake or real is to compare many different sources, and then look at a little bit about the background of the source, who is giving you the source, their motivations, comparing, and always going back and forth between reality, that is the ultimate source of everything, and who say what, right? But with mathematics, you have to be careful sometimes, because there are misinterpretations, there are wrong way applying, in particular with statistics, right? Statistics is probably the part where you can manipulate more mathematics. But again, if it is about real numbers and data, it's again much more difficult to do that. So I'm inviting everybody to actually do what Plan C is doing. But this morning, when he was discussing the cycles, I was a little bit disappointed, because basically he was doing what I say we should not do with Bitcoin. That is, we look at a bunch of things around us that we think they can influence Bitcoin, like, oh, Trump just got elected. The ETFs, or this other person saying this, or Sailor saying that he's going to buy such and such amount of Bitcoin. Sure, these things are important, and we should keep them in mind, and we should have them in our radar. But it's extremely difficult to go from these things to a price prediction, because everybody could do that, right? We will say, oh, because now sailors say this, then the price will continue to go up forever. And Based on what? You don't know exactly. One could do a little bit of calculation, like, for example, we'll say, okay, given that he say that he's going to buy such and such number of billions in given amount of time, what is the impact? That is that actually among the different use a little bit more concrete, right? We can actually spread that amount of money or with their entire period, compare it with which kind of flow is needed for Bitcoin to leave a power law, for example, or to stay on the power law. And these are calculations that are actually did. And no, Sailor is not going to change anything because it's going to be a drop in the bucket in comparison with what is needed for Bitcoin to continue on the power law. But just saying, oh, we have this institution coming in, we have Trump administration. It's just a bunch of words, okay? And I see so many people doing that all the time, just saying, oh, because of this, and this other. Okay, were you able to do the same thing in the past and predict things even like the power law and say, oh, because this and this and this other? No, most people didn't, because they didn't even know that there was such a power law. They have been wrong over and over again. So my approach with these kind of things is not use a bunch of words or use some ideas that you may have that you think that can influence Bitcoin, because you have no idea what is the impact. You don't know if you are going to execute. You don't know when it's going to happen. Is going to push the price momentarily up? Is the price going down? You have absolutely no clue about these kind of things, and nobody has been able to do any type of prediction based on just hand waving, what they call hand waving. The only type of predictions that Bitcoin allows us to do is based on things like this, is based looking at a pattern that we already have and then extrapolate this pattern to the future. This has been working for a long time, right? With the power law in the first place, with cycles too. These are very strong regularities that no other asset has, and only Bitcoin has. Okay, and this morning people were saying things like, oh, the cycles is not something that we find in other assets. Well, first of all, it's not true, because Michael Howell, for example, and other people that studied global liquidity, they found regularity. They found these patterns that are now before years regularity, that maybe they are not huge, big cycles like we see in Bitcoin, because in Bitcoin, everything is amplified. And Bitcoin responds differently from liquidity, and it has properties that are different from other assets. But it's not true that there are no cycles in other assets. There are. It's just that they are not as dramatic, as precise, and as regular as Bitcoin, the one in Bitcoin. So that is my philosophy, okay? And if people don't like that philosophy, there are plenty of other influencers that can tell you all kinds of different things about this happens, this other happens, and then this other will happen, and they aren't entertaining. They tell you interesting, things that people want to hear at the moment, like, oh, we are going to the moon and this other, and nobody never double check them, because few days later they talk about something else, and because it's all about entertainment. It's all about entertainment. It's never about giving concrete, real information, actionable information. It's all about entertainment, okay? And there are plenty of people. In fact, almost everybody else does that, and very few people will look at in a very precise manner the cycles or the type of patterns that we find in Bitcoin, and then extrapolate them to the future and make reliable predictions. There are very few people that do that. So I want to focus on that. So that is my first concern and criticism of what Plan C said. And it's not about Plan C. It's about anybody that says we are not going to have a cycle this time. We are going to have an extended cycle. The cycle happens before it's supposed to happen. All these claims that are based on very little, or just basically feelings and not real data. Okay, so after this premise that it took quite a little time, but I needed to explain it. Let's go in depth. Okay, let's go in depth and see what Bitcoin tell us, because that is our philosophy, right? Among the people that follow me and in this YouTube channel, in my X account, etc. We only focus on what Bitcoin tell us. Okay, what can we learn from Bitcoin? Now we can add other information, but it has to be also quantifiable information, like for example, information from the liquidity, that is basically the interaction between Bitcoin and the external world. But all math, all physics, no talk, no BS, even if I talk a lot so far. So let's see. This is one of the best charts and where I would like to start, right? So, and today they were repeating over and over and over again, and they were saying Bitcoin power law doesn't say anything about a cycle. All right, let me discuss that, okay? And again, it's not that I am the ultimate authority on the power law, but I discovered the power law. I have taught other people the power law. Of course, they, even a student can go and do something different from the teacher, improve on what the teacher says or whatever. But I still think I do have some leg up in comparison with other people, because one among the other things is what I do from morning to evening. I try to answer these questions in many different ways, using different tools and so on, right? And then what matters is the evidence. So I'm going to show you the evidence, and then we can discuss it, we can debate it, we can think about it, and we should always be open to reality. So whatever Bitcoin does, in the end, Bitcoin does, right? We will be able to understand it, monitor it, compare, with what happened before, and then say, oh, okay, now it looks like Bitcoin is doing something different. So let's start actually from this graph. Let's start from this. So in this graph, what I did, so you can see in light blue is the price of Bitcoin. Okay, here it is. I did it a little bit transparent because I wanted to have it there as a reference, but it's now where the highlight of this graph is, right? So we go, this is, you can see, it's unfortunately, I'm using TradingView. We don't now have a log function where we can see the straight line, but the red curve is the power law. It's there are different ways of representing the power law. One way is drawing it through the entire set of data, in which case it represents some kind of middle ground between the tops and the support line, what we consider the support line. This is not quite the support line. So basically what I'm doing here, I'm calculating a moving average, so over 4 years, right? So this is the moving average. The reason why the moving average doesn't start from the beginning is because it needs 4 years to be calculated, because basically it works, how the way it works, you look at, for the people that are not familiar with moving averages, you're looking at the past 4 years, at every dot, in this case, we are doing it daily. So for every day you look at the last 4 years, and then you calculate an average, and that is what the value of that particular point is. Then you go to the next point, you look at the previous 4 years, and you do it again, right? You do this over and over again. And of course, the first data point cannot be calculated until we do have 4 years of information, right? So this is why it starts here. So this is a yellow line, that is the moving average. And you see it's pretty consistent, right? There are some oscillations, and these oscillations seem associated with the bubbles, right? But because we are averaging over a long period of time, it is 4 years, they seem to be much more flat, right? They seem much more flat. Here, this is supposed to be like a bottom, because we're taking the average over 4 years in the past, and here the price was much lower, right? So we do this over and over again, and we get this very regular curve. And this oscillations seem to become actually smaller with time, right? They go down. Here, for example, the two lines almost match with each other. Now, this power law is basically a feat of this curve, right? And you will think, because I want, everything I do, I'm going to explain it in the most precise way and tell you both of the advantages of doing something, but also the limitation, right? In this case, we have a moving average that I didn't even need to, calculate anything. I could have just left this as it is, and you see it forms this curve pattern that we are so familiar with. But I fitted a power law to it, right? And this is the red curve, what the red curve is. And it doesn't need to start here, because once you find the parameter, the slope, so I calculate basically the slope and the y-intercept of this moving average. And it gives me this red curve. It could go all the way to when Bitcoin was created, because it's supposed to start to a particular date. Now, when you measure the slope, it's the usual slope that we get. It's the usual slope for the power law that we get. Now, the only thing different is the y-intercept, right? That tell us basically, so I could write a bunch of power laws that are all parallel with each other with different y-intercept. The y-intercept is less important. I can shift it even arbitrarily. I can say, okay, shift it by this amount, because maybe I want to show that if I shift it by a certain amount, from the center, I catch all the major bottoms and so on. We don't know which one is a real power law, right? Are these different power law? Is there one power law that basically generates all the other? Because if I have all the data, let's say right now, our main idea is that there is one power law that is basically a power law that goes through the major bottoms at exactly the same slope than all the other power laws. And it represents, very close, it's an approximation, because data is always messy. And when you're doing these theoretical calculations, you're doing an approximation. And so this is why it looks so nice and so perfect, etc. Nothing in nature looks that perfect, but it's nicer to calculate, it's nicer to extrapolate, it's nicer to visualize. This is why we do mathematics, because we are trying to find order in disorder, right? And there are many things that are orderly, but they are always some what we call noise, right? Some level of uncertainty, right? So the power law that we think is the real power law, it's something very close to this one. This is not exactly that, because I didn't calculate in that way, where there are different methods. You could select just a certain number of data points that are, you can do it, what you can use, what is called the quantile method, where basically you're looking at the entire distribution of the data points, and then you're selecting a certain amount of data. And then if you select a small amount of data that are basically the data points that are more extreme on one end of the spectrum in this distribution of data, that are the one that are, let's say, if there is a distribution, it's not, if you look at the distribution of the deviations from the general trend of a power law, you have you don't have a very symmetric type of distribution. It looks it has a long tail. The majority of the data points are on this side, and so if you look at these data points, then if you select them, they form this support line. Another way is to do a classical regression, where I actually kind of prefer this second method, even if it seems a little bit more arbitrary, and I will explain you at a certain point why different methods have different advantages. But you can draw a line, you can calculate the power law in between, and then deviate, find a deviation that is about 60% from that general trend. And that seems to touch the majority of the data point at the bottom. It's like a support line. And when we did certain different calculations, and not just me, but other people, we're seeing that line seems to be associated with how much it costs to produce Bitcoin. So it has actually a physical correspondence, a physical connection. It is really, really interesting, and it's very difficult. It's fascinating in one way, and at the same time, it gives you a lot of confidence that there is something real there. That is not arbitrary. It's like all these things are like pieces of a puzzle that you put together, and when you start to see many pieces come together to form a picture, you're confident that what you're seeing is real, right? Does it look like a lion? Yeah, probably is a lion, right? I'm missing a few pieces there, few pieces there. Probably it's not going to be, unless there is a surprise and it's some kind of weird creature with the lion head and the body of an eagle, something, but when start to put more pieces together and they see the body and it looks like the lion, it's probably a lion. Okay, maybe it has a funny tail or something, but the picture becomes clearer and clearer, and it gives you confidence that what you're seeing, it's real. So this is how it's work with Bitcoin in general, and in particular with these studies around the power law. So there are other methods to find this support line, and the nice thing is that basically they all converge. Even this very rough way of just saying, let me take a long term moving average, and 4 years is good because basically these are where the cycles are. They last about 4 years, so we tend to almost cancel out the cycle. Now, they do cancel out in the sense that when you see deviation from the trend, they reach a top and then they always go back to the power law. The reason why they don't cancel perfectly the moving average is because you're doing it dot by dot and you're always looking at the 4 years before, and there is never one single point where you could say, hey, if I go 4 years back, that is the entire cycle, right? Because there is always noise. So if they don't cancel, and also when you're doing it here, right, you're still, you don't have a full cycle, right? You don't go back and all these cancel each other. You will have to go from the beginning to the end, and when you see that the cycle, basically the price cancel each other because always goes back to the power law. So this is why you still see bumps here. This is why they are not completely eliminated by the 4 years moving average. But you see, it flattens, the 4 years average flattens these bubbles, and it comes closer and closer to these general power law that is very close to what the support line is. So there are different ways of doing it gives you the same answer. So in one end, you could look at the red curve and say, and that is basically a straight line. If I did a log-log graph, it will look like a straight line. And you have seen that graph many, many times, right? So I do have a version here. Let's see if I can find it. Yes, this one. I do have a version that a company called LuxAlgo, we did a collaboration. I don't know how to do it. I would like to learn, but there is a way of going around the limitation of TradingView. And the reason I'm using TradingView is because I want to interact with graph. I want to zoom in. I want to show you the different things. If I use a static picture, you will not be able to see all these details that I want to show you. But there is a way of showing the power law in TradingView, like if it was in a log-log graph. It just requires a trick. Like here, we created basically an additional x-axis, like an arbitrary x-axis that allows us to plot it like if it was in a log-log graph. I didn't create this graph, so I don't know how it was done. At a certain point, I would like to reproduce it, but here it is, right? So it looks like a straight line. The general trend looks like a straight line. And there are, these are the different deviations. So the one in the center, the green is the support. You see how the support touches all the major bottoms. So you're looking at this straight line going back here, or it looks curved when you're just taking the log of the y-axis, and you keep the x-axis linear. So it looks like this curve like this. And by the way, it's an illusion because that curve is not curving down, it's curving up, right? It's just that the only thing that will look like a straight line in a graph like this will be an exponential. So if we have an exponential pattern, it will look like a perfect straight line. And Bitcoin is not an exponential, right? Because it doesn't look like a straight line. It is something that I repeated many times, and it should be something that everybody tests at a certain point, particularly with ChatGPT. You can tell it to make an exponential and then show it in a linear chart, in a log linear chart, in a log chart. Log linear means log on the y-axis, x is linear, right? In fact, if I turn off the log here, you can see how the power law looks like. Okay, power law looks like this. It's a J curve, right? It almost looks like exponential. In fact, it is related to exponential. They are similar. There are similarities. One has the power law differently from the exponential as a curbing mechanism. Basically, the changes, everyday changes, how much the price goes up, it's curbed by the age of a system. Every day you will have to divide by how old Bitcoin is. And then that will be your new change, right? So as you add up all these changes, they are curbed by this factor that is the age of a system. And an exponential doesn't have that. Like an exponential multiplies by itself by the same amount every day. That is the difference between an exponential and the power law. But this is how it looks like. It goes up. It goes up like people use the word parabolic, and they many times they mean exponential. They don't mean parabolic. Because parabola it's x squared, and it's actually a power law. It's not an exponential. And I told you the main difference. It's a big difference, right? One grows in a constant fashion, and the other one grows very quickly, but it has this curbing mechanism, right? For the naked eye, you will never be able to see a graph like this and say, is this an exponential or is this power law? This is why we use math. This is why we use all this technique. But the beauty of mathematics is that it gives you very powerful insight that your naked eye cannot. Sometimes you can learn things from the naked eye. Other times you cannot. So I look at the graph like this. Is this exponential? Is this a power law? Which kind of power law? So it's a power law that grows faster than a parabola, because the parabola it's x squared, and this one goes with the power of 6. Okay, so you see it's going up. That is what anybody that says, oh, what Bitcoin is very volatile, it goes up, it goes down. We are missing the point. We are not understanding that there is a general pattern, and these bubbles are just noise, right? In a sense, yes, they are noise. They are not the main signal, because when you study data, there is always a signal that you're looking at and noise, right? And it depends what you're doing, because sometimes the noise is the signal. It depends where your focus is. If your focus is the general trend of Bitcoin, the general path where we are going over a long period of time, the signal is clear. It's this red curve. We are going up. And see, the beauty of using TradingView is that we can zoom in, and I can show you that the curve was there from the beginning, right? You don't see, it looks flat over there because in the beginning, because these prices are so small, and this is one of the reasons why we use the log. But you see, this curve has been the same curve over and over again. We call it scale invariance. This is another idea. If you ever wonder, when I say scale invariance means that the curve look like itself everywhere. I'm going here, so everywhere at every scale, even when the price was very small, it looks the same type of curve, the same kind of curvature. It's all the time the same. Okay, so it looks like the same. The same. And so that is what Bitcoin is, this crazy growing curve Look at this. Look at this. Okay, this is a signal. That is a real signal. Okay, I need to shrink it to actually being able to look at it, right? Yeah. So this is what it is, and it's amazing. It's going up, right? Numbers go up. It's true. This silliness of the bubbles. Yeah, there are these weird things called the bubbles, where the price leaves the power law, but then it comes back to it every single time. See, it goes back to it. It goes back to it. So in general, you can say that is what matters, the power law. That is, if you're interested in the general trend, that is where your focus is on the power law. It is this curve that continues to go up. Now, will it continue to go up forever? I don't care about forever for now. What I care is the next 10 years. Let's focus on the next 10 years, maybe 20 years. Will it continue to go up in this way for the next 20 years? Yes, I think so. There are a lot of evidence, and there is a lot of reasoning and mathematical thinking that tells you, yes, it's very likely that we never know because we cannot predict the future, but it's very likely that it continues, right? So this is the idea that in general, it's like the bubble don't exist, right? Okay. And now if I go back to the log on the y-axis, the cool thing about the log is it allows us to see all the pattern without zooming in, because now it looks like that. And if you go to the log, we take the log of time, then it looks like a straight line, but it's even cooler. And what allows us to recognize this as a power law, because even doing the log of a y-axis, okay, now it looks much cleaner, it's much more easier to follow, but I'm not able to say what it is. Okay, it could be a complicated curve. It doesn't have to be a power law. What I know, what I can exclude by looking at this graph, it is an exponential. It's not an exponential because, like I say, if it was an exponential, it would look like a straight line. Okay, at a certain point, I could add a curve here that is an exponential, maybe in another video, and then I can show you when I click log, it's going to look like a straight line. Maybe next time we can do that when we meet. I'm going to have more of these videos where we talk more about the theory in general. Okay, we can go deeper in the theory, deeper in the ideas, and so on. In a certain moment, I will take some questions and interact more with you. I wanted to introduce the basics. Now, I just said that at the first level, the power law it's not just that it doesn't say anything about the bubble. Actually, it says a lot about the bubble. It says that they don't exist. They don't count. They don't matter. It's noise. Okay? So when people say, oh, the power law doesn't say anything about the bubble, they are wrong, because it says a lot. It says they don't count, right? That they cancel out. They do not matter. It's actually saying a lot. Before the power law, that was not the case at all. People emphasize a lot of the power law, the bubbles, and made them kind of a central story in some of the other models. Like, for example, with S2F, according to S2F, everything happens during the bubble. Most of the motion of the growth of the price happens during the bubble. It's not true. They cancel. The bubble don't matter. Now, the total result of 2 years of bubbles, because we go 1 year up and then 1 year get down, is that they give us the power law. But the power law is there. You see, this is one of the other reasons why S2F is really a garbage model. And I'm not so strong with all the other models. There are not many others that are even in the ballpark of being a competition with power law. The only one, not because it's valid or it has any substance, is mostly because how popular it is and how many people still believe in it. This is why another reason why I'm so strong, because it's not envy. It's being an educator. I don't even understand when people say, "Oh, focus on your things." Are you crazy? Are you completely out of your mind? imagine like a scientist and somebody tell them that there is this other theory that says that the Earth is at the center of a solar system. The scientists will be upset. They will say, this is garbage. This is stupid. Let's say, maybe you will ignore it, like people that believe in flat Earth, and you will not try to mess with these ignorant people. But imagine it's something that millions of people follow, and this person that goes around and tries to educate people on what Bitcoin does, or what the solar system does, says these absurd things. You will intervene and you will say this is absurd. Imagine even something more consequential, like, for example, medicine, where this person, and I'm not talking about some case where we don't have all the information yet, some COVID, like I know people are going there with their mind, COVID alternative approaches, etc. I'm not even touching that. Something that is super well known and understood, and this person will say something, where we need to do this to the liver, and he's clearly talking about the heart, and he doesn't even know the difference between a heart and a liver, But we're talking about stuff like that. And so, of course, you want to intervene. Of course, you want to mention what is wrong with that approach. It's part of doing science. You go explain what is correct and also what is wrong. So one of the arguments about S2F being non-valid is because you can see when we are far away from the bubble, like in this region, we are still going up, and we are going up along the power law. And nothing changes because in that 2 years, right, you see I mentioned here, this is a very nice breakdown of a cycle. So we were talking about a cycle. So let's go through here, and then I will explain you how this compares with other ways of understanding the cycles. So my understanding of cycle works in this way. So first of all, what did I do? So what you're seeing here, the top panel, it's the usual power law, right? So the usual power law, the main power law, it's in the middle. Then we have the support power law, with this lighter white line here that probably is the real power law. And the middle one is kind of a compromise between where the bubble are and the support. Because what we're doing now, we're going from saying, yes, the power law says there are no cycles, and actually we can use the power law to tell what the cycles are and what they do. That is the next step. Is almost, imagine, we've seen that meme where there is the guy, from, I don't know his name, he's like a leader of organizer of these wrestling matches, and I think he's from a video where he looks at a girl or something, it's dancing for him on his table or whatever, and he has different expressions, right? And there are different craziness level of expression, right? So the first one is say, which I should make a meme like that. What are the bubbles, right? There are no bubbles. The power law says there are no bubbles. They cancel each other, right? So that is the first level of expressions of the face, right? And then you go down to more enlightened level, so craziness level, where the guy loses it, right? Because the girl is doing more and more crazy stuff around him. And this is what happens with the power law. So the first level is, there are no bubbles. The second is, wait a second, I will have to throw my eyes in the garbage not to see these bubbles. They are there, they are clear, they exist. So what can we do about that? Or should we ignore them? In the end of this talk, I will tell you, no, we should not ignore, because you know where I'm going. That actually we can use the bubble to do things. You don't have to, but we could do that. Again, it's part of an enlightenment picture where some people stay there and they don't need to go deeper, and they can be happy about the power law going up and telling us it's doing that amazing curve, and you're a hodler, and this is actually all what you should care. You should not even care about the bubble. Okay, maybe they can be fun, the price can go up. Which fun? What is the fun of seeing your portfolio going 3, 4, 5, 10 times like in the past, up, and then crash 90%? right? I don't call that fun. I call it frustrating. So, the only reason why you will be interested is because you want to go through a different level of enlightenment. And maybe when you arrive there with some knowledge and understanding, etc., maybe you can take action. You can use it at your own advantage, and we can discuss that, right? What can we do once we understand the cycles? Okay, but it's a separate discussion. This maybe even if you are an hodler, you just want to understand Bitcoin, you want to understand the role of the cycles. You don't have to do anything about it. So it's all first we focus on understanding them, right? So the next level is, okay, I do see the bubble. Okay, you're right, they do exist, right? They seem to cancel each other. You leave a power law, and let's go through this discussion, right? So there are these events where we seem to leave a power law, the general trend, and then we go back to it, right? These bubbles. And they seem to be super regular. And remember, I say, I want to listen to Bitcoin. I don't want to listen to anybody else, Fred, Plan C, anybody that tells me a story. I don't care about story. I want to listen to Bitcoin. I want to analyze Bitcoin through the data and what it shows me, okay? So to compare the cycles, I did a shift. So basically here where we are today, I went back in the past 4 years, because this is one of the things by studying Bitcoin, it looks like there are these very precise 4-year cycles. We know also that 4 years is not by chance, is associated with the halving, right? Now, what exactly in the halving is producing the cycles, we can also discuss. It's not what S2F says, it's not supply shock, something completely different, okay? But they seem to be associated with the halving, okay? So I go back 4 years. So imagine I am here, I go back 4 years, exactly 4 years. So today is going to be in November 11th, right? So I go to the equivalent of 4 years ago. So that will be in the 20, right? I go to November, and it will be around here, right? So this is the 5th, 12, good enough, right? So here, so this is where 11, right? 11, you see, Wednesday, 11, 2020, okay? So I go back 4 years. Then what I do, I take this segment and I shift it, okay? I shift it by 4 years. So now it's perfectly aligned with the current cycle. So you see, this is the second cycle, okay? And it's the third cycle, okay? Here is the third cycle. This was the leftover, the second cycle. So this is the third cycle, and it's aligned with the current one, that is the fourth cycle, okay? So this is exactly where we were. Looks extremely similar. Look at this, very, very similar, right? In terms of where we are relatively to the support level, where we are relatively to the general trend, very similar, okay? Last time, 4 years ago, we kind of touched the power law. We are still a little bit away from the power law. By this time, we already touched it, okay? So this is where we are. And they did the same thing with the previous one, right? The first cycle. And this year, this is where we were. We were much closer to a support line. This full model tries to do both the top and the bottom, so it doesn't give us perfectly the support line, but close enough. Right? It's trying to do too many things at once. By the way, these are all equations. See this purple line, it's an equation. You can write it down on paper. It's really incredible that you can represent so much of Bitcoin behavior with an equation. You can write it down on a piece of paper, and this is why we can extrapolate it in the future, like I'm doing here, because if I know what the equation is, I can substitute, instead of the past days, I can substitute the future days and project it in the future indefinitely. I could project it for the next 10 years, 20 years. That is the beauty in trying to be predictive. Everything we do here is predictive. We are trying to make predictive model. It is very unique. Almost nobody has models that are predictive. Everything else is moving averages. All these things are always based only on the past, and we are not able to projecting the future. Yeah, you could extend of it moving average, but it doesn't mean anything, right? Now, in the case of Bitcoin, that moving average, if you do it long enough, it's close to the power law, so you're kind of doing a power law, but in insight, right? In our case, we are actually trying to find the real mathematical equations that describes the behavior. So it's a prediction. So, and you can see, this one was more of a textbook example, because the theory says, so the theory behind the cycle says, we have these cycles, they seem to peak at very precise time, and this is what we use as our beginning of a cycle, the top here. It's a convention. I could have started at the bottom, I could have started anywhere else. We like to start at the top. Now, when we say top in this case, and we also use this terminology of a clock, okay? Basically, you can put the 4 years in a clock. You can actually literally do that. I will show you a graph of that in a moment. And then may call the different stages, different seasons. You could use the language of the seasons, or you could use the clock terminology, right? Where you have 12, 3, 6, 9, right? And you go around the clock, the digital clock that many young people don't even know how to use anymore. That is sad. You should learn how to do it. It's cool. So anyway, when you say top, the other thing we do that is slightly different from what other people that even in the power law circle, other people that study this type of regularities in the cycles, we use instead of using blocks, we use a human time, because human time, I think, is what we respond to. We don't know about block time. Yes, if you're a geek, you can go online and check, and you can think, well, but Bitcoin will respond to its natural time, that is the block time. I don't think so, because nobody really cares. I don't think even the miners care about block time. It's there, and it's variable, because these are 10 minutes events are in average 10 minutes, but some of them can be longer, some of them shorter. It's interesting. And usually if you substitute block time, you get something similar. It's not different enough where it's something that you will make a strong argument that is important to use. I like to use human time, because I think you will respond, right? It's about seasons, it's about holidays, it's about things even like elections, they happen in human time. And buyers, because of course Bitcoin will still respond to the action of people. It's a social network. It's part of our theory of why we have this power law behavior. So the local behaviors and the general behavior responds to the seasons, right? So the end of this every 4 years, right? So it doesn't happen every year, but the end of a year that is associated in many countries, even internationally, where Christmas is not celebrated, with the end of the year, Christmas. There are a lot of things that people and companies do accounting at that time. People in my country, in Italy, for example, I don't know if it is still true, but it used to be where they split stipends in 13 amounts, and then they give you an extra check. It's still the same. You're still making the same money. It's just like basically they are saving for you. It is silly. I think in America they relate to it, because you want to be in charge of your money, right? Even if you are not. But it's a way of giving you an extra check when Christmas comes, so you actually can spend it. It is silly, but you can imagine the impact in the economy, right? Having this 13 check coming in once a month, right? People get paid once a month, most in Italy, like that. And then all of a sudden, an entire nation, or many people in the nation, get this 13 checks. So it creates like some liquidity, right? So, and I don't know if they do it in other countries, right? There are many different things that are associated with the end of the year. So to me, it's very important to consider that there is this end of a year that is associated with what looks like the top of a cycle, right? So we call the top of a cycle 12. That is basically around the end of a year for that year, where the cycle tops every 4 years. So, for example, last time it was the 21, then it was 4 years before, so 18 and 13, right? So if you go back 14, sorry, so 14, 18, 21. So you go 4 years every time. Yeah. I mean, the end of 21, the beginning of 22, the end of 17, the beginning of 18, the end of 13, the beginning of 14. You know what I mean. And the next one, if you project this cyclic nature of Bitcoin, it is, look at this, right? You can argue with me and say, oh, I don't think so. It's not that precise. This happened a little bit before. This happened. What are you talking about? These are oscillations. These are changes that, and there is not a pattern, because you see, this one was a little bit later. This one was a little bit earlier. So if you say, oh, they are becoming shorter, what are you talking about? It's just fuzziness that you will have with anything that is not perfect, right? It's noisy. It's already amazing that we have this level of precision. It's within, let's say, plus or minus 1 month, right? So usually we don't go beyond the end of the year. So this one was December 21st, the peak. This was 29 of November. So this was end of November. This was up in a little bit early beginning of November. So within a month, let's say, of the end of the year, 1 or 2 months, we have these peaks. Okay, so this is the 12 that I mentioned here. Now, what about this? Because there is a lot of controversy. I had some discussions with this guy that makes an alternative model of these cycles. I think his name is Leo. It's a pretty good analyst. I don't like some of his approaches. Like he introduced an ad hoc function. We have this model that is like what I call the full model. It is trying to replicate the tops. It's trying to replicate the bottom. It even has a decay, because the size of these bubbles are becoming smaller with time. So you're already having 3 pieces, 3 components that are, every time you do that, you're adding 1 parameter, because what is the length of the cycles, where is the peak of a cycle, how fast the decay happens, where the bottom is. You're introducing all these parameters, and you're going away from the beauty and simplicity of the power law. The power law is so powerful because it's basically only 1 parameter, the slope, right? Because the y-intercept is a little bit arbitrary. Are you drawing it at the bottom? Are you drawing it at the middle? It doesn't matter. It's not that important. What is important is that slope, because the slope tells us the change, how the change is happening over time. And so you go from something that is basically 1 parameter to something that has 3, 4, 5 parameters. And when you do that, you risk to basically follow the noise instead of a signal. And there was this famous mathematician called von Neumann, was like a genius. And in fact, he was making fun of an Italian scientist, Fermi, that usually he didn't make fun. He was making fun of you. But in that case, he was trying to describe some complicated phenomenon in physics where he was using 4 or 5 parameters. And he made a joke. Von Neumann make a joke saying, with 4 parameters, I can fit an elephant, and with the 5th, I can make his trunk wiggle too. And actually, literally, somebody created a function where it looks like a kind of very stylized elephant, and with 4 parameters, you can perfectly fit it. And then they were able to create like a little algo with a 5th parameter where it looks like the trunk is actually moving. You can make it like a little animation, like by changing it over time, right? As a function of time, and it's wiggling the trunk, right? So it's nerds fun, nerds type of fun. Okay, for us this is fun. So I find it super funny. You can look it up. They even have the animation of a little elephant. But so you have to be careful. And this guy Leo introduced one more, where it's a very clever actually idea, when I reproduced it, and when I was very surprised, because he's able, by introducing this new factor, it's basically a factor that makes the length of the cycles change. And when he does that, in the beginning I was skeptical, because I thought, how could he do that? See, we have a problem of the first bubble that happened at a different time than the other ones. It was about 2 years distance from this one. So how could I? My way of approaching this is to call this an anomaly, because first of all, it happened before the halvings, and even if the halvings are not associated with supply shocks, we are still, in my understanding of the bubbles, they are associated with the halving. I will explain you maybe later why, or maybe we can have a second episode of this. But exclude it. It's a scientific thing you can do. If you have a strong motivation, there is a behavior that is an anomaly, you can call it basically an outlier, and you can exclude it from your data. So I don't include it. I'm saying I think this very regular behavior started to happen when we started to have the halving. They look very similar. This looks like the oddball. I'm excluding it. He doesn't exclude it. He included it, but with the price of adding this additional parameter. And remember what von Neumann say, if that is the right pronunciation, hopefully I pronounce his name correctly. He say that you can try to fit anything, right? So it's easier and easier to fit anything by adding additional parameters. So I don't like so much of that approach, and I don't see anything gained by introducing this bubble as one of an additional bubble. Maybe, if we have in time more information where is models, because there are consequences too, like for example, if you take at a face value is model, then the next bubble is going to be in April. My prediction is going to be November, December of next year. So if it turns out that he actually is right, and there is evidence for that, then we will have to reconsider, and maybe he's correct, right? Maybe Bitcoin does this. It has this complicated way of changing the length of the cycles, and this function is the correct one. The other consequence of using that model is still based on the power law. If he uses the power law as his central point, because basically what we do when we do this complicated model of the oscillation, we use the power law. So that, remember, we go to the next level where you say, oh, the power law says there is no bubbles. The two actually use the power law. This is how the power law is related to the cycles, where our understanding of a cycle is all based, and we have a language to describe what the cycles do, how they behave, all based in describing them as deviations from the trend. If you didn't have a power law, you could not do that. You are talking about this deviation, how big they are, how regular they are, is all described using the power law as a point of reference. So you go from the power law saying there are no bubbles to actually use the power law to describe a cycle. See how it goes. It's different level of depth and understanding. Okay. So in his model, I was saying this curve here will peak here instead of peaking here. So it's a let's say it's in the same family and is adding some interesting twist. So we will see when things like these are going to be decided by more data, because unfortunately, differently from the power law where we have thousands and thousands of data points, we only have 3 bubbles. That is one of the limitations. And Plan C was mentioning that. It's true. It's also not true because in theory, it's not just the peak, it's the entire cycle. The fact that the cycle behaves in a certain way. So you can superimpose these 3 cycles like I did many times. And then you see these irregularities. It's not just by drawing some line that I found the irregularity. Believe me, every time I say and claim something, I do it in 3, 4, 5, 6, 7 different ways. Right? One way I did it was by taking these cycles and then superimpose them and taking an average and see Do I see a pattern? Because if it was noise, the pattern will disappear. If there is a signal, actually the signal will reinforce itself. But in particular with things like sine waves, that is actually a standard technique. You take a periodic signal with you're thinking will last this amount of time. Even if that is one of the things I did when I was working in astrophysics. We couldn't see the signal at all. So you had to guess, you had to use many different. I was working at LIGO. These are how they do certain things at LIGO. They use a certain amount of data and say if there is a signal there that is covered by noise, because noise dominates, you're not even able to see with your eyes. Then as I add more and more noise in this window, let's say it's a signal that lasts 1 minute, right? Take 1 minute of data, you add 1 minute, 1 minute, 1 minute, 1 minute, 1 minute. And they have many cycles, right? Because LIGO has been in operation for years now. And so you can do it over thousands and thousands of data points. And if there is a signal, this will work with a periodic signal. By the way, they didn't find yet any signal like this. That is one of the reasons I left the field, because it was very frustrating to look at noise all the time. But eventually they found signals, but different from this periodic signal that I'm describing. But if you have something periodic, it's actually a cool exercise if you know how to code. Make a sine wave, add a lot of noise to the sine wave where you don't even see the sine wave, and then randomly choose different periods, right? Like say you made the sine wave 1 minute, but then you choose 35 seconds and sum up all these 35 seconds. You will not see anything. But if you do it correctly, so you try many different combinations, and there is a signal with that periodicity, at a certain point, you will see the signal. It's really amazing. It's a beautiful idea. The signal cancel because they don't support each other, but because you have a sine wave, all the peaks will be aligned, all the trough will be aligned, so they kind of add each other. So the signal grows while the noise cancel each other. With this, it's you're already seeing the signal with your naked eye. It was just another way of confirming it. But if I put these segments of 4 years together, you can try different periods. But you can try also that and see if they will not see a particular pattern. But if you do it right at 4 years, you see this particular pattern. That is basically the average behavior of a sine wave. And the noise, it's not completely canceled, because if we had hundreds of these cycles, then yes, it will start to cancel completely, and you will see mostly the signal, right? The noise will go away. But it's still noisy because we have only 3. So I would not say that, sure, it's only 3 cycles. It makes a little bit the stats weak, but it's not only 3 cycles in a sense, because it's basically almost the entire history of Bitcoin. And it's all what we have, but it's very consistent. They are repeating themselves in a very precise pattern, and they are there. They cannot be denied. They are, they have been the majority of the life of Bitcoin. I will say, so in terms of certainty, we go backwards in this Enlightenment meme, right? In the sense that closer we are to the beginning, more certain we are. Maybe we are less enlightened, maybe as another form of enlightenment, right? Some of these Zen stories where they say you do all these crazy things and then you go back to where you were when you were a simpleton, or the other meme where there is a guy, there is like a bell curve, and there is the idiot here, then there is a guy in the middle, and then there is the enlightened person that does exactly what the idiot does, but he knows, he has the awareness. That is the difference, right? So you go back to the beginning and you have that awareness that in the end, our base, our backbone is the power law, right? So I can agree with Plan C, for example, in saying it's less certain that this cycle will continue relatively to how certain we are, or how non-certain, or different level of uncertainties, if you want, right? It's all probabilistic, so we should never say certainty. It's just a number, right? It's not 0 and it's not 100, right? It's somewhere. I will say the strength of a power law goes around the 90%. We can use the R square if you wanted to. It's 95% certain that will continue to exist in the future. One could make even stronger arguments based on the invariance property of Bitcoin and all kind of stuff like that. But the cycles, yes, they give us deeper understanding of Bitcoin because they are part of its history, but at the same time, they create some element of uncertainty because we are more complex. We need more variable to describe it. So, as we go down, the level of uncertainty and the level of you are exploring the unknown, basically, right? And so it's a trade-off. There is always a trade-off. But right now, I will say the cycles are on the order of probably 80%. I will have to make a stronger, think about how one could make a mathematical argument of that. But using my intuition right now, so take it with a grain of salt, I will say something on that order because they are consistent, they happen at a very precise time, they are associated with real events like the halving, and they are a part of Bitcoin. They are being integral part of Bitcoin. So we don't know what would happen if we didn't have the cycles. We don't know. For example, if we will have even a law. I mean, in theory, no, because if you're looking at my other work, right, with the work that I have done with networks, etc., showing that it's all about the adoption, and the adoption also doesn't know about the bubble. In fact, actually, if you're looking at the addresses are even less influenced by the bubbles. They do have some bumps, but the power law of the addresses doesn't it doesn't get affected so much like the price. But it does get affected. In fact, I have some studies where I use network properties like the strength of the links between the nodes in the network, where I can show if I change the strength of a network, the strength of the connections, and allowed for periodic changes, you get the bubbles. Actually, you could explain the bubbles as changes in the property of a network. So, we don't know. And this is something that, believe me, I would like to go deeper and explore more and understand more. There are many analogies that we could make. Like, for example, how pulses in the neurons, how the neurons communicate with each other. They communicate through these it's called axion potential, right? So they are creating these spikes of electricity, and they travel through the axions, right? So they travel through the axions that are these connections between the neurons, and they don't work like normal wires. They have almost like little relay stations, because there are gaps. There are gaps between. There is like a long connection between one neuron to another that starts from one neuron. And then when a neuron tries to communicate with another neuron, there is like a little gap there, right? And so they need to jump, first of all, between these gaps, but also as the signal travels, it tends to decay, because we don't have copper wires inside us. Even with copper wires, right, you need to have transformers that enhance the electricity. They do different things to electricity, so it can be carried over very long distances, right? But with the neurons, you have these places where basically they work like almost like relays, right? They bring in ions from the outside, etc., and they from the outside environment, and they enhance the signal that is being decayed, this electrical impulse, and so the signal can continue to travel through these biological wires, basically, by these regular pulses and enhancements. So an analogy that one could use is that maybe the bubble work in the same way, that the fact that we continue on this adoption path is because there are this period of excitement, innovation, etc., that kind of give bursts and pulses to the continuous growth of Bitcoin. That could be a possibility, right? And I'm doing a lot of talk, but I'm also making an analogy with phenomena that do exist. And right now, we don't know. If we cannot really exclude it. In one level, the theory says, well, I will not need that if I have a regular adoption curve. It is also a power law. All what I need to do is continue that, and I will see the growth. But we don't know, because the adoption doesn't happen by itself, right? It needs to have some kind of driving mechanism that attracts people to the network, and people like seasonality. People, we since our birth, as a civilization, etc., we have followed the yearly cycles. We are very familiar with cycles, right? And the 4-year cycle is a new thing, maybe like it's not even too new, right? Why do we do, for example, Olympic Games, World Cup, World Cup soccer competitions every 4 years? There are a lot of things that happen in 4 years because it's not as short as 1 year. And so if it is something relatively important, symbolic, like the Olympics, etc., you probably will not want to do every year because, it will not mean a lot to be the champion, the current champion of a particular sport, right? The gold medalist of a particular sport. But if you did it every 12 years, it will be too long. The athlete is not young anymore, and will not make much sense to do it. So 4 years is a good amount, right? It's not too long, it's not too short. So maybe there is something like, it was Satoshi picked it up, right, for particular reasons. Direct reasons or indirect, like unconscious reasons. Maybe he had in mind 4 years was kind of similar to these other events that are happening at certain intervals. It's not too short, it's not too long, and so on. So seasonality is important for human beings, and so we see this seasonality in Bitcoin, and it should not be ignored, because my entire philosophy, like I said, differently from everybody else, is instead of making some vague argument that are not supported by evidence, if I make an argument like this about the pulses, I want to support it by evidence. We see these pulses, they are there. We don't know if we will have a power law at all. And it's a big statement from me, right? Because in one end, I would like to say, no, we don't need the bubble for the power law. The power law will be there no matter what. Maybe. We don't know. That's the point. As a scientist, we should say we don't know, because you see, remember when I say we use the power law to describe a cycle? Well, if you take the price, and that is how we do it to describe a cycle, and you subtract the oscillations due to the bubbles, you are left over with the bubbles. You're not left over with noise. That is the other point of contentions. And I can show you this graph, right? I'm going to show you this graph that I have with plant C, for example, right? So heat likes match is kind of enamored with this quantile method, and it's all based on basically describing the power law as a power law, and then subtracting the trend and making some statistical determination about what is left over. But this what is left over, in fact, we can look at it in different ways. Oh, I kind of eliminated, oh my God, eliminated what I should not have eliminated. Just a second, give me a second. Okay, it's back. So when you subtract the trend, you subtract the price from the trend. Let me see. Okay, you can do it in different way. Like, for example, what you can do, you can calculate this quantity called the percent difference. So what do you do here? You take the price, you subtract it from the trend, and then you divide by the trend. And this is what you are left over. You see? If the bubbles were just pure noise, you will see a bunch of dots all over the place, right? It will be just random dots. And there will be a middle that will be zero, and some, because this represents deviations, right? Remember what we do: we take the price, we subtract from the trend, right? It is the power law, and then we divide by the trend and multiply by 100. So you will have a percentage, and some data points will be above the power law, so we'll have positive values, and some points will be below. And so if that was the case, we will see like a cloud. We will see a bunch of dots all over the place. They will be dispersed, right? They will be all random, all around some kind of zero point of reference. You see it here, it's this dotted line. We will see all these dotted points. We don't see these dotted points. We see a pattern. We see a very precise pattern that is related to these bubbles, right? We see the bubbles. So this is a signal. That is another. Nobody. I never hear anybody talking about this in this way. In fact, some of the criticisms, there are even people that criticize the power law, they say, "Oh, you don't get," right? Some of the literal statistical people that don't look beyond the statistics or the textbook understanding of things. Early on, now very few people even attack us through these arguments. But in the beginning, in particular, a lot of economists will say, and they will use fancy technical terms, that are even difficult to pronounce. But basically, the bottom line was you should get some random noise. If you really found a pattern and the pattern was meaningful, what is left over should be random. It should be like if you look at the distribution of this stuff, should look like a bell curve. And you don't get that. Yeah, they didn't even plot it themselves. They calculated, they use this fancy language. And they try to basically, if you try to understand the meaning behind the word, there is a pattern. There is a very precise pattern. Yeah, of course, because there are two signals. There is not just one signal. There are two. There is the overall pattern of the power law, and there are these oscillations on top of it. See, it's two different signals. So you could try to eliminate this second signal, but it's much more complicated. One could use a model for them and then eliminate these. I tried, but it's complicated because, you can write a formula, but, where exactly the peak is, it's complicated. It could be done. And then, in theory, what is left over then should be noise. But first, you need to eliminate this second signal, okay? And then, yes, whatever is left over. But you see, now this becomes a feature. It's not anymore a bug, because if I see a second signal, I can learn from that second signal. There is a pattern. There is a precise pattern. So you cannot treat this, whatever is left over, as if it was noise, right? So this is one of the problems with the quantile method, where you say, oh, look, I see all this stuff. I'm going to make a distribution. It will look like a weird distribution with a very, very long tail. But basically, you're calculating a distribution of some noise, because there is always noise, but a lot of signal too. So there are special ways that you need to treat these and understand. It's not that you cannot do a quantile graph. You can, but you need to understand where it fails and what it's trying to tell you. I have such a graph, but so there are different ways of treating these, right? So one interesting way of showing, you can see from this graph what are some of the things that we can learn from this graph. First of all, one of the things that we kind of mentioned a few times, but we didn't explain, if you measure this deviation relatively to the trend, they look much, much larger in the beginning. This was the bubble that happened before the halving, was enormous, right? So if you calculate it in terms of percent, then it's 1,500. So basically 15 times. So it represented a deviation that was 15 times big relatively to the trend. And then they started to go down. Like this one was more 11 times the general trend. This one was This was the one in the end of 13. This was 500%, so 5 times. And the last bubble, if you use this as the peak, that is what we use, was 177. And so that means about 1.7 times, not even 2 times from the general trend, right? It doesn't mean from where the bubble started. It means from where it should have been if it was not a bubble, right? The price just below the peak. I can show you what I mean from this graph. So, okay, so if you go here, right, and the peak is here, we're talking about here, right? So if you go just below until you get the central power law, because this is what we are using to, you could use the support line, and some people do that. I'm using the central line. So if you use a central line, that the graph that we just show the difference between the central line and the peak. So in that case was not even 2 times, 1.7. Okay, so yeah, you can see there is this decay, right, of decay of the peaks. Now it turns out, and this is one of the things that completely surprised, because Bitcoin is one surprise after another. If you plot these graphs, in fact, we could try. It's not super clear from here, but I'm trying to take the log of this. Maybe it works. So if you take only the peaks, let's see if we can do it. It's much more clearer if you just look at the peak itself, right? And just one dot. But here is less clear, but let's see if we can make it work. So I'm going to draw a trend line, right? So it turns out it's much less impressive if you do it in this way, but I'm still trying to make a point. Maybe if I do it in this way, yeah, I think this will make the point clearer. Yes, I think this works. Okay. Yes, I think actually it's pretty cool. Yes. All right, look at this. And I'm not in the beginning when I actually have an entire article, because many times when I do this work, I'm trying to write articles. I eventually want to actually write scientific papers to actually talk to the scientific community. And the process, it's just like I'm so distracted with everything else. It's taking much longer than I thought. But and you never do it just by moving a line around, but you do it in a more mathematical fashion. You calculate these deviations, but in general, if you plot these points, these tops, okay, there will be some distance, right? So if the top is here, the line is there. I'm doing it by hand right now, but you can do it mathematically using this method called regression. But it's very striking when you actually plot only the data points. You can see very quickly that they form a straight line. And it's only 4 data points. So this has to be taken with a very, very, with a grain of salt, and you have to be very, very careful, and you have to, we are almost in meme territory when we're right here, but not really, because at the same time, it makes you think, why something that is driven mostly by FOMO, and it's very rational, because now why the bubbles deviations go down, it kind of makes sense, right? It's much easier to move an asset that was worth only a few $1 million to something that is worth trillions of dollars, right? So of course I will see smaller deviations here than here, but why they should follow such a very regular pattern? So this is an exponential. Remember when I told you, see, if I draw the log, and then I see a straight line. It will not adapt. Like if I do this, it will still keep, because it's not an equation. It's something that I drew by hand, so it's not going to adapt. It doesn't know that I'm trying to make it look like an exponential. This is why it looks like a straight line here, right? It doesn't work. I will have to draw, I will have to calculate, and I can do it. I should do it actually, the exponential, and then make it as a function. And then in that case, if it is a function, it will adapt when it changes. I go from log to not log, it will show the exponential. Right now, it doesn't. This is why it's actually nice to work in these spaces like the log linear space, because if I draw a line like this, and like I say, the computer does it for you when you do the regression calculation, it means there is an exponential. And then you can measure the slope of this exponential. That will give you the rate of decay, how fast this exponential is decaying. If this was a real line, instead of being something that like an equation, instead of something that I drew by hand, it will look like it's connecting all these dots like this. Like it will look like a curve that connects all these dots. I will do it for another video so you can see what I'm talking about. But what I'm trying to show you here, that even these peaks, and it's not like a technical analysis where people draw lines by hand and they try to give interpretation. This is math. If you see a bunch of dots, that of course there is noise, right? They form a straight line in a log linear chart. It's an exponential decay. So even this, it's regular in Bitcoin. Is this just a coincidence? Is just something that has no meaning? I don't think so. It seems that even this decay is somehow linked to the power law, because we are calculating, remember, everything is calculated as a deviation from the power law. So maybe this is the hint that connects the power law in a very, very precise way with the cycles. I cannot figure it out yet, besides like some hints and some intuition, like this one, that actually there is a strong connection that is deeper than what we think. But the fact that this apparently random event, and they happen in very precise times, but also their decay, it's a mathematical function, it's a clue. It should tell us something, you know? And so, again, instead of saying, oh, the cycle will not repeat themselves, or we are beyond the cycle right now. No, we should study them and understand them. And another way you can represent them is, instead of, and it's something that I did, because I come up with something every single day, maybe not every single day, but at least every week, I come up with something new. And in the last few days, I was actually trying to show that if you focus on statistics and you play this game where you say, okay, there is a signal, but let me randomize this signal so it looks like noise. Is there some kind of a pattern that you can find? I don't know if you saw my post. I was able to show that it's almost like there are two regimes, right? There is a regime where Bitcoin spends a lot of time near the support, and then it spends a lot of time above the support, and even that looks very collimated. It's almost like there are two possibilities, like on, off, on, off, on, off. And of course, there is fuzziness. But when people say, hey, the power law predicts this huge, big range, it's bullshit. They don't know what they're talking about. The power law tells us that we spend a lot of time, in fact, it's almost close to 60% between the support and the middle trend. But even more than that, it looks like when you look at all these dots, go back to my X and look at some of the posts I made in the last few days. There is this dark, you see all these dots, because basically what they did, they took all these dots here, from this, let me go back to the linear way of representing the data. I took all these dots and I randomized them, right? Because otherwise the pattern distracts me and it doesn't look like noise. You say, let's pretend it's noise. So I randomize, not the size, but the order, right? So I kind of scramble them, right? And initially looks like noise, but because it's not noise, you see that there is a lot of data points that kind of cluster at the bottom. So this is how you study these things. Say, see, it doesn't look like noise. It looks like there is something different there. And so a lot of points are all clustered here. And it means that Bitcoin is spending a lot of time close to the support, right? And even when you think about it, like if it was noise, like I say, let me forget that there are very precise timing in these cycles, and it's not that when you're close to the support, it's not that all of a sudden the price can go where the model said it can go during a bubble. It's ridiculous. That is part of a misunderstanding of a power law, because there are these very precise cycles, and the power law allows you to tell you where the heck you are in the cycle. So it's information. Like Wayne, for example, that is one of the people that helps Fred with the cycle. He's a good guy, but sometimes he loves to simplify things to that, where then information is lost, But it's okay. Everybody plays a role, right? His whole role is to simplify things, but sometimes simplify them too much. He was saying, oh, there is no other information besides. No, it's not true. You're saying untruth. Yes, there is information. In fact, using the power law, you can exactly know where you are in the cycle, right? You can color code it. You can tell, this is what exactly we do here. You can tell if you are close to the bottom, close to the top, how far. It gives you a lot of information. Now, you can pretend a game, you can make a game where you say, I'm going to scramble this dot and I'm looking just at a statistical property, like if it was noise. It's a mistake, but maybe you can learn something from that. And one of the things I learned, because when I do it, when I say, okay, let's do it, so maybe I learned something. I learned that I kind of knew it already, but it's a very cool way of showing what is this clustering, right? That most of the time we spend here, close to the support. So from a probabilistic point of view, then you should take it at face value, say, no, the power law tells you that we spend most of the time over there and not over there, So it's not true that it can be anywhere at any point, because probabilistically, no, where it tells you most of the time we are, You see how it works? Now, there is a better way of doing that, because we also spend some time here, right? When we are not close to the bottom, we spend time here in these red areas. So it will be silly to say, oh, we can go all the way to the support, you see, until we have evidence that this cycle do not exist. And even if you play this game of randomizing the data, thinking like if it was noise, the stats tells you something, because the bottom line is that it's not noise. Like, now you will have to completely be ignoring everything, when treated like noise, think there is a Gaussian curve, etc. You can calculate the mean, you can calculate the standard deviation. This is what the quantile method does. It ignores all these things, and it treats it like noise. Like it's kind of a little agnostic, so I'm saying something not completely precise. It doesn't need to know what is the distribution, but it kind of works like that, right? It tells you that there is almost all these lines, like for example, plan C draws all these quantiles line. It's almost like all these quantiles lines are possible level for Bitcoin price. No, they are not, because most of the time the price is here. And if you do it in a certain way, because it also depends on how you define these deviations. So if you do this type of deviation, where instead of dividing by the trend, so you do price minus trend, and then you divide by the price. Why I do it that? Mostly because I want to handle this decay. You see this decay and say, what if I divide by the price? Because the price seems to change, right? The price here was different from the price over there. So if I do that, and this indicator has different options, I do that, look what happens. Okay. The tops now, they look normalized. That means they seem to have similar heights. Look what happens. And in fact, it's really cool, because not just the top seems to have a similar heights, also the bottom seems to be very close aligned. So it looks like most of the time we spend time here or here. And in fact, if you go and look at my graphs, that I just show, if I randomize now this, I scramble it, and so it looks more like noise, you see that there are two regions. Now it's not anymore all like a cluster of data points here. There are two clusters. There is one cluster here, and there is one cluster there. And we spend most, so it's very precise. The power law is super precise, even more precise than people thought, even the people in the know that already knew that it's precise. It's even more precise because it's telling you, no. It's not true that it can be anywhere. It's mostly here during, in fact, it's not that we can switch. Oh, I am here, and then all of a sudden, 2 days later, I'm over there. I am here, then 2 days later, I am there. No, I am 2 years here and 2 years over there, right? Because even, in other words, when you try to throw away the cycle from the door, it comes back from the window. Or you throw it from the window, it comes back from the door. It doesn't matter, even if you treat it as noise, the property of a noise are still there, where it tells you, I'm not noise, I'm signal. Don't ignore me. Okay, if you can ignore it, but then you will kind of do almost like a mathematical mistake. See this how normalized now these cycles are, where most of the time we spend it here during the bubbles and during the when we are not in the bubbles, because it's 2 years here, 2 years here, right? If you go back to this graph here, where is this? Yes, you see, it works in this way. We spend 1 year going up, where the behavior is exponential. We go down 1 year, where the behavior is exponential. Very, very precise. Look at this. Starts here and here. 1 year. Okay. And then we spend 2 years close to the bottom. So when we are here, we cluster there, where I say at the bottom, in a very precise way. And sure, there is some deviation. It looks symmetric. It's not perfectly symmetric. It's not a bell curve. It has a little bit of a tail, but it's much more symmetric than if you took the entire distribution, because the entire distribution is not symmetric. But the two distribution of the data points here and here, they are somehow symmetric. This one looks even less symmetric. It's in fact, it's what is called an exponential distribution, but it does have some clustering. When you use that normalization trick that I told you, then you do see a little bit more symmetry. Otherwise, without that normalization, you will look like an exponential decay for the distribution too. If you do the trick of normalizing, and so you can call the deviation whatever you want. You can use a deviation that make more sense that because of this decay that we observe. And in that case, there is more symmetry. And then you can define, and I'm going to make a new indicator that basically separates the data into regions. One region is what we do when we are way from the bottom, from this support line, call it the bubble, whatever you want to call it. And my position is until we have evidence that something is different, that we are not following this pattern, because right now every single piece of information shows that there is nothing different. It looks almost identical to what happened last cycle. So there is no reason, even the timing, everything, right? There is only one thing, that is the liquidity, that we can include. We are talking 2 hours, I don't mind, because these are in-depth analysis. But we can have also another episode where we go deeper in the liquidity. That is the only thing that is different. But so far, we don't have a liquidity that characterize every single other bull market, right? So something is different. Now, is that different temporarily? Temporary thing? Is it something that we have to deal and we have to interpret? We don't know it yet. Okay, we will have to see. But that is something that I wish it was similar, because it will mean, the bull run started. We are going in the right direction. We have a right support from the liquidity, and it's actually something that goes against the exponential people that think we are going from this moment on exponential, that we are not going to follow the cycles. We are going exponential, we will find out in a year if we go back, right? This is what Plan C says. We are not going back. But then I don't understand because it's saying two contradictory things. After the call this morning, I thought, I should have asked him this question. In fact, if you plan to see, listen this, or maybe later, I will tell you, come here and listen to my video. Please answer to this question, because we can have a discussion. Maybe we can even have a video together. What do you think he's going to do? Tell me exactly. Draw on a graph like this. Use trading view, etc. Because you can draw stuff, right? You can draw things. Let me see if I'm using a brush. What is he going to do? What is he going to do? What Bitcoin is going to do? If he doesn't follow this pattern, you have in mind, because he was saying that he still follow the power law. So he does this. But right now he's doing this. It's going up very quickly. And that is the other thing that we need to discuss, right? The returns, right? What are the returns? Because you can learn a lot from the returns. That is another indicator that we have. Right now, the returns. So the return is price today over price yesterday, right? And you can learn a lot by which kind of returns we have. Right now, for example, we can switch that. Do I need to say anything else here before? I'm drawing a bunch of stuff. Let me see. So we were talking about this distribution, right? And I'm going to make an indicator based on that. You can see from my X I posted, because many times, by the way, I'm using my X almost like a journal, so I apologize if you see a lot of my posts, but instead of having this flash post, with a very well clean chart, I discover things and then I share them with you. It's a different way of doing it. I know that some people find it annoying, but it's a genuine way of bringing you in my discoveries, in my exploration. So this is why I post something. I should find a compromise, like maybe spend half a day on something, and maybe at the end of the day post what I found instead of every 20 minutes, But it's kind of a naive way of getting excited and sharing things with you. This is what is behind that posting a lot. But you can see, the evolution of what I did, like the last couple of days, where I was showing, look, the distribution is not a bell curve. We have this in fact, if you have a sine wave and you randomize a sine wave, this is exactly what you will see. I can actually show you how it looks like. It will look like, most of the time, the sine wave, the data points in the sine waves are in two regions, right? Have about kind of, in fact, people who study electrical engineering know, because it has to do also with the cycles in the power, right? In the electricity power. And we have this concept of RMS, root mean square. And they know that it's about 60%, some 65%. It is basically most of the data points, because when you come close to the top, right, you are going down very quickly, right? You're reaching, you're not changing the velocity very much, then you're going down, right? But you're not spending, the place where you're spending least time is when you're crossing the zero, because you're going very, very fast. So you're not spending a lot of time close to the zero in a sine wave. And this is why we don't see a lot of data point in the middle with Bitcoin, because we are all the bottom or at the top, kind of in the middle between the top and the power law, the middle power law. And it's exactly the behavior that you will have for a sine wave. It's the statistic, if you want to talk about stats, is the stat of a sine wave. So even when you were saying, I'm not going, like this is what Plan C was saying, I am time agnostic, but then you use the stats and you're trying to describe Bitcoin through stats, and the stats are the ones from a sine wave, because this is what you're left with when you're subtracting the general pattern. You cannot avoid it. It's math, and you have to understand, because intuition brings you so far. That is the difference between somebody that has the training and has the time and spend the time, and every single day. It's when I was teaching my students, I was saying, you learn these things in this way, right? You have intuition, and some people are better than others in intuition. You get some insights, you explore in that direction, and then certain things are supporting your intuition. You were right. Other things surprise you and say, whoa, I didn't expect this, because your intuition is not developed enough, right? It needs training. And so you go back, and the math helps you to understand that you were wrong in something, because the math is always right in that case. And so you integrate this new information, and now you're making another step. You're trying to understand something else, and you go deeper through your intuition. And again, you're using math to support this new intuition, and you go back and forth. It's like two legs. You're moving your understanding of things. That applies with mathematical things, but probably with anything in life. If you could use this, right, where you go deep with your intuition, then bring evidence to support your intuition, or deny sometimes, and then you improve in your understanding, and you continue in that way. Maybe you can think a spiral, like a spiral or something. But yeah, this is how it works. But I knew enough, because of experience and because of my intuition is more trained, that if you have something like this, and then you do the stats, and this is why I randomize it, it will look like the start of a sine waves. You cannot avoid it. You cannot avoid it. And this is why it's much more precise than people think, because from a statistical point of view, it's telling you there are these two regimes. We spend this is what I was also trying to show here, but now I'm going to have a new indicator of it. It's really creating two regions using these normalized deviations. And it's telling us, look, most of the time we are going to spend it here in the middle, right? There is actually a region where we spend most of the time when we are here. And when we are here, there is another region where we spend most of the time. This is really, actually, if you wanted to come up with a fair value, that region is your fair value. Better than anything else from a statistical point of view. And it will be based, until we have evidence that these cycles do not exist anymore, and Plan C or anybody else gives us some alternative of how the cycles look like this blue line instead of this purple line. There are two regimes. It cannot be denied, even from a statistical point of view. You can try to deny, but then you will make a mathematical mistake. So it depends on which regime. So if there was somebody like British Odell or Joe Carlasaret, all these people will say, oh, the power law gives you this huge... It's a way for them to dismiss and not want to learn stuff because it's too difficult, maybe want to change their mind or whatever. Whatever motivates them. And they are saying something that is not true. No, the power law tells you that a huge amount of time, like I say, 60% in between year, by the way, and probably, close to 30-40% or even more, we are, and in fact, during that season, during these 2 years where we're moving along the power law, is more than that. You will have to double it or more, because it's almost impossible. We are going to be there, so we are going to stay here, and we are going to stay close to that cluster. So we could calculate it's really close. It's probably going to be close to 80%, close to this very, very narrow region where the price is supposed to be statistical. So it's very precise, very precise. And then when you switch and you are in this region, then there is an equivalent band over there where we spend most of the time. That is the second level, right? Then you can go to the third level and say, well, actually, there are very precise pattern, and we are going up. We reach a certain point where we can pinpoint the top, and we can know exactly how fast we are going down, etc. And these where these graphs of the volatility comes into place. See, I have all these tools that we can use to explore and go deeper and understanding Bitcoin. So these are, and this also is part of what I was trying to discuss. I didn't ask this question, but I'm going to ask this question now in a slightly different way. So what anybody that doesn't think the cycles are going to be there think we are going to do, okay? Because all we do, this exponential growth that I described during this next year. This is the next year, right? Now, what happened after that? I think the cycle will repeat and we go down, etc. But if people think there is an extended cycle, are we moving exponentially in the next year? Are we moving up like this? Where we are going to end up, right? And they say, oh, I don't care about that because I'm just saying in general. I don't know. What are you saying? I don't know what he's saying. I'm confused. So are we going down eventually? Because if we don't go down, I don't understand how you think we can go and continue along with power law. Or you're saying, there is not really a strong, precise bull. We do all kind of random things, but in general, we move along with power law, right? Is this what you're saying? I don't know. I would like to, instead of guessing, I would like to know. I think it doesn't matter what he's saying. It will be a guess, right? Why what we are saying is not a guess? It's not, because we are saying, we are giving all these reasons why the cycles will continue to exist, right? We are very strong. We are component. There is no evidence of the contrary. We have been existing. Now you can go deeper and start to talk. Like, you will have to read my article. I wrote an entire article. We can discuss it in a moment. I want to look at the data, and then I can tell you why I think we have cycles in the first place, and why they are so important, why they will exist in the future. But first, let's finish to look at the data. So this is another important component of looking at the data. It is basically the returns, right? So these are returns. You can choose the window. Right now, I'm averaging them on a moving window of 90 days. So the scatter you see here are the returns on a daily basis. They look like noise, right? They are all over the place. Someday we have a positive return. Okay, so this is basically, remember, it's a ratio between the price today over the price yesterday. So if we are above 1, means 0% return. Gain, right? Return technically is this ratio. So I call return 1, the return minus 1, just to make it a percentage, right? So to make it a percentage, you have to take the return, subtract 1, and then multiply by 100. So if it is 1, right, the ratio is 1, the return is 0. So we don't make anything. Anytime we're above, right, so if you see one of the spiky line above, means that day was a positive day. Otherwise, we had a losing day. And you can see it doesn't look like there is a pattern. It's just noise, right? We go up and down, up and down. But now when you average, there are patterns. There are very precise patterns, right? We go during the bubbles, for example, we tend these returns when we average over certain periods, and you can choose different period. And now we're doing it over 90 days. They go up. They go up in a very, very consistent way, right? Then, of course, when we go down, and so on. Okay, so you can follow the different. When we have bottoms, we are usually below 1. Now, if you take long-term averages, like over a year, etc., we almost never go down, right? But go below 1. Not down. But right now, being below 1 will indicate periods where we are actually losing. We're going down. We're having bad days, right? And it's a sequence of them, right? Because we're averaging over 90 days. So it's very interesting to see how these returns, which returns pattern we see. By the way, the blue line represents the theoretical return from the power law. So if we were always on the power law and we didn't have bubbles, what we will see, what the daily returns will be exactly the blue line. The blue line tells us what are the returns, the theoretical returns from the power law alone. Now, because it's a moving average here, and it needs a certain amount of time before it's even calculated. I think I'm probably calculating over a longer period than it doesn't matter. It will look kind of the same because it's consistent, right? There is no noise, so it doesn't matter over which moving window you're calculating. But probably I'm using a moving window bigger than the one that I'm using right now for the daily returns. But notice how the daily returns oscillate around this blue line. That means basically the same thing that we have always say, that the power law is some kind of statistical average behavior of a Bitcoin price, right? So it's a deeper property than just a straight line. It's really what Bitcoin is doing, even from a statistical point of view. And you see it's oscillating. That means that basically the blue line represents like an average return over time. And these are daily return. We could calculate yearly returns, etc. The current daily return, due to the power law alone, it's about 0.1% a day. And you can see, if we are looking at the last 3 months, for the current one, we are close to 0.27. The way you read these, remember, you subtract 1 and you multiply by 100, right? So that 1.0026 that you see there, that is the current return average over 3 months. It's 2.6 bigger than what the power law says. The power law says 1.001, so 0.1%. So this one is 0.27%. It's much higher. So how could it be that we stay on the power law if we continue with these returns? We are going exponential. So all we have a cycle where we give, see, that is another way of thinking about a cycle. It's kind of a valve, like a pressure valve for Bitcoin. That all that pressure that maybe right now is being built up because people are tired of whatever, having these 0.1% returns, or actually having this correction for a long time, for many months. People get excited because of election, etc. All the the halving, that is another psychological event that creates a lot of FOMO, a lot of enthusiasm. They need to have some kind of pressure outlet. And this is what happens with the bubble. They get excited. There is this big pressure for the price. It goes exponentially, leaves the power law, and then the price inflates and it corrects itself. So it's kind of a mechanism actually for staying on the power law and allowing these events where people get excited for 1 year and then they get depressed for 1 year. It's human nature. The bubbles represent human nature, and this is why you can have this incredible scale invariant behavior over many, many years, and at the same time letting people go to Cancun and have fun. It's great that we are both. And so if you're telling me, we are going to have an extended cycle, okay, then what? That will mean to be on the exponential path for longer period, unless you mean something else. I don't know what this means, so I would like to have a discussion with it. But anybody that says that we can have both the power law behavior and an extended cycle, they don't know what they are talking about, because that will mean to stay too long on the exponential path, and then we need a correction. Now, in theory, we could have an exponential growth for 2 years and then go down 2 years. But why? If we did something different all these other years, there is no reason for that, right? There is no evidence that is going to happen. Probably 1 year is all what the market can sustain under an exponential growth. Maybe cannot sustain 2 years, because people don't realize that is the other thing. They don't understand it, how they don't understand scaling variance. They don't understand exponential growth. If we go up, right, you can calculate easily what is going to happen. So imagine we continue with this growth, right, of 0.27, right? You know how to do that. I kind of explain how to do it a few times. You take this number, so you can also do it. You can do it together with me if you want to learn something. Take 1.007, Okay, 27. 1.0027, right? That is what this chart tells us the last 3 months of average returns have been. Okay, so you take that number, then you take the power, right, with that caret sign, the power of 365. Why? Because that is what returns mean. You take the return today, you multiply by the return tomorrow, you multiply by the return the day after tomorrow, and because it's an average, right, we can use that average. So you multiply all these returns, that is equivalent to take the power of these, how many returns we are going to have. So if you do it for a month, for example, I get 1.08. That 1.08, you can do it with me if you like. Do a calculator. Take this number, take the power of 30. That will be 1 month. In 1 month, we are going to do 8%. So we are going up 8%. Okay, let's do it on 1 year. 1 year will be 365, right? You take that, we're going up 2.6. In fact, you see here, I put this line, 0.33. This is what will be needed for us to reach 200K. We will need to have 0.33% for an entire year to reach 200K. That is about 3 times from where we are right now. So 0.27 give us a similar value, 2.6 times over 1 year. Imagine if we have an extended cycle with 2 years, right? We went up with this exponential behavior for 2 years without a correction, without a bubble crashing or whatever. We went up 2 years. That will be 7 times, okay? We're going up 7 times in the next 2 years at this rate. Now, if we accelerate this rate and we make it faster, it will be even bigger than this. So this is a relatively moderate rate that will allow us to reach 200K if we just do it for 1 year. But if we even do it 2 years, we are talking about 7 times. What happens if we do it 3 years? You can see this is a non-linear and it becomes pretty crazy. So it's 20 times, right? Can we go up 20 times? Where the money is coming from? It's crazy. I already calculated if to stay on the power law, we will need for the next year $200 million every single day coming in. By next year, it's going to be already 300 million because with the power law, the price is going up and so on. 300 million. In 3 years from now, it's going to be 600, right? In 5 years, if I remember correctly, it's like $1 billion. Where the money is coming from every single day. How is it possible? People don't do this kind of math, right? They are not realistic. They are not thinking correctly about this. Just this to give you an idea, we will need 2 times more what we have done in the last 3 months in terms of return to reach 500K. And it needs to be consistent. It needs to be, remember, every single day, this is an average per day to actually reach that value. So I don't think so, right? I would like to be surprised, but the problem with these surprises is how healthy they are for Bitcoin. Is it healthy for Bitcoin to go 7 times up in the next 7 years when we never had that, right? We saw growth by a factor of 10 during a bubble, early on when the asset was, when the price was $20. Okay, this is what we had. This is another problem with using the same stat, including the first early event, and applying it to today. I'm talking about the stat of the bubble, not the power law. The beauty of the power law, it's scaling variant. You can say, yes, the behavior that we had early on is the same behavior that we are having right now because it's scaling variant. The bubble are not scaling variant. So this why we are seeing the decay of the tops. So you need to be consistent. You need to have a picture. All the little pieces of the puzzle need to come together. And right now, the most coherent picture that we have cyclic behavior, that the bubble are decaying, that they are lasting 1 year, because probably 1 year is all what the market can take of this crazy exponential behavior. It showed 4 different times that it doesn't like it. for more than 1 year. 1 year is okay. You can have a little vacation and you can go crazy exponential. It has a role, but then the market wants to correct, and that is good. So I'm going to stop for a second and take some questions, and then maybe we can go back. Okay, a lot of questions. So I apologize if I was focused on the story. And okay, consider Bitcoin. So Junie asking, and then after this we can take a break and maybe return tomorrow, some other day, talk about liquidity. Maybe we can kind of give a preview, talk very quickly about liquidity, and then come back and have another episode only on liquidity. Okay, so considering, Junie is asking, considering Bitcoin as a reserve asset for US, especially if the US government start purchasing it, what do you think the price will be in 12 months? Look, I'm going to do eventually a study, because I already did it with the ETFs, right? And I already told you the main problem when you do this kind of study and say, okay, given this income, this given inflow, what the price is going to be. Actually, it's relatively simple, because you calculate the how many coins we have. If it was simple, you will take nothing is simple like that, but you will take the number of coins available, you take the price, and we know we use the power law, we project the price for the future, we know how big the market cap, what is necessary to change the market cap, because what come in needs to be the inflow. The difference in the market cap needs to be in the inflow. It's a relatively simple calculation. The main variable in that calculation is this multiplicative effect, because people say, listen, when $1 comes in, it's not going to move the market cap by $1, because what happened is there are a lot of coins that are lost. There are many coins that are not moving because where people are holding. So there is some kind of multiplicative effect. $1 is going to move the market by 10. I will be nice. Now with the ETF, we have some real measure, but it's also incomplete, because is the ETF the only thing that comes in, right? So we could maybe calculate that multiply effect, and I'm going to do it. That is one of the things that I want to explore and calculate. Imagine that only the ETF were coming in, right? Like you can always do that, like a kind of extreme case, right? Your minimum, your worst case scenario, only the ETFs are coming in. And then we can see how much the inflow shifted the price. Not much, to be honest. So I don't know. We can calculate the multiplicative effect for that. Right now, when I do my calculation, I'm using a factor of 10 that I think is actually on the side of being cautious. I'm probably smaller than that, but that is where the problem is. Of course, you can always do a range. You can say, okay, if it is 5, it's going to be this. If it is 10, it's going to be this. If it is 50, it's going to be that. So that is the only big question mark that we have on this type of calculation. But it can still give us some insights. But in general, I will say, the theory says that, and I have done this little talk so many times, that everything happens in proportion to Bitcoin. You will not see a power law if it was not that at every particular time in the history of Bitcoin, the type of resources, the type of investment, the type of events, even negative events, positive events, everything happened proportionally to Bitcoin. Not because it's magic, because it's logic. You will not invest. Like imagine a nation investing in Bitcoin when it was, $5. Maybe some nations did. If they did some, they took some coins from a criminal or whatever, they kept it in some place. They didn't sell them. Many times they did sell them because they wanted to do with, the $5 right now. They didn't think that one day it will be $1 million, or they didn't even have a infrastructure to do that because there are maybe laws that force them to sell them. Nobody really was operating at that level. They didn't include this understanding of Bitcoin. They include the understanding of where Bitcoin was, the impact of Bitcoin. It was considered a meme coin when it was $5. Now we are taking it much more seriously. So everything that happens to Bitcoin happens based on where Bitcoin is. One analogy is a snowball, right? The snowball attracts snow that is proportional to its surface. As it goes down, it becomes bigger and can attract more snow, and it becomes bigger and bigger and bigger and bigger, right? So imagine a snowball effect like that, where whatever happens to Bitcoin is proportional to how big Bitcoin is. So are we big enough where USA or some large nation is going to do an investment that is proportional to where Bitcoin is? I don't think so. Yeah, they can do some early moves that are not very different from other moves that they did, like they already own Bitcoin. So they can talk about the reserve asset. Maybe they can start to buy a little bit of Bitcoin, but nothing serious where it's going to be on the order of what Bitcoin will need to leave a power law. It's not going to happen. In fact, it's not going to happen even something that is proportional to Bitcoin itself, because I think there are, with these big events, it's almost like even if everything is proportional, all the other events, they happen at the right time, in the sense that are on and off, right? It's not that the reserve is going to grow until it's going to be something as influencing Bitcoin price. Right now we can do it symbolically. It's kind of a preparation for that, right? We can talk, we can kind of psychologically prepare for the idea. We can even bang a little bit, to signify that we are thinking about it. But the big event that all of us are waiting is when basically the US say, beyond actually the reserve, they are saying we are going to peg Bitcoin, the dollar to Bitcoin. That is when the power of a nation like the United States will be felt on Bitcoin. That is going to happen, in my understanding, and I want to do a deeper study on that, when basically the economy, like the GDP, for example, of the United States, it's equivalent to the market cap of Bitcoin. When that is going to happen, 10 years from now, 100, 20 years from now. We should not do any speculation beyond 20 years, because anything beyond 20 years, we don't even know how the world will look like. In particular, with AI, we could have a singularity. The Kurzweil talks about AI could take over. We don't know. Okay, so let's keep it between 10 and 20 years max. I think by 20 years, because we can calculate, Bitcoin will be $100 trillion asset. That will be equivalent to the real estate in the world. And probably at that time is when big nations like United States, Russia, China will pay attention. And pay attention means something big will happen, maybe hyperbitcoinization. And then the story of a power law ends, because remember, the story is how we went there, how we went from using the dollar, because you could do these using the dollar, using gold. It doesn't matter. It's the same thing. People say, oh, gold is better. It's not, because gold doesn't change. Yeah, it went up by a factor of 2. It's nothing when you're talking about something where it went up by a factor of 10 million, like Bitcoin. Literally nothing. So it's all flat. This is why you can use them as a point of reference, right? As a unit of exchange. You can use the dollar, you can use the euros, you can use the yen. They are all basically not changing relatively to Bitcoin. They are flat. They are, if you express the value of the dollar relatively to Bitcoin, it's going down. It's going to be a power law that goes down. Same power law, but going down instead of going up. But that is the idea. That is the idea that once Bitcoin reaches values that are on the order of 100 trillion, then this is when big nations will pay attention and will go beyond just a reserve, right? Because a reserve, it's not much different from what ETF or even Sailor is going to do. I think the big influence of the nations will be when they decided to actually peg their, maybe even do completely without. Maybe there is no dollar, maybe there is no yen, okay? Or they are pegging it to Bitcoin. So there will be some huge event like that will happen, I think, and we can try to do a stronger argument, maybe looking at similar event in the past when El Salvador came in, how the economy El Salvador compare with, for example, with market cap of Bitcoin. Do we see a pattern there, right? That there is a proportionality between some economical measure of that entity with where Bitcoin is. I'm pretty sure that one can make an argument like that. It's just nobody has done it yet. I kind of a little bit did it. I have a little graph where I show where gold is, where different companies are in terms of their market cap and how they compare. This is why also a company like MicroStrategy is completely involved with Bitcoin and not a company like Apple. You know, when people made a big deal about Microsoft or Apple, whatever it was, discussing internally, it was like almost like a joke. Somebody decided that they it takes like not much. You need to own just some shares in Microsoft to make it, to file a petition, to have a discussion about adopting Bitcoin or buying Bitcoin through Microsoft funds. Anybody can do that, but it's cool. It's actually, you see, nothing happened, but the fact that it was on the press, the fact that people discuss it, the fact that some people, that dreamed that actually something was going to happen, meant something. It's part of these, cycles of events that are all proportional. The day that Microsoft actually will do it will be because Bitcoin it's at the right place where that action will make sense for them. Maybe when the market cap of Bitcoin will be equivalent to the market cap of Microsoft, or maybe some kind of a multiply of that. See, this is how it works. At least this is my understanding. Now, if you have a different understanding, we can discuss it, but this is how I think about this. Yeah, I mean, actually, so Mr. Orto asking, do you still believe the bull start in November and bull end 20K in November? Right now, there is absolutely no evidence on the contrary. In fact, actually, I will say, given the behavior right now it's a little bit difficult to separate what is bull and what is enthusiasm about the election. Okay, but maybe the two are connected. This is why 4 years ago the election was over. It was more or less during this time, and we had a bull. It started more or less during this time, so it's possible that the bull, we can declare the bull started. I will give it a little bit more time. We are going to watch it closely. A big event will be when we are going to cross the power law. That will be an important landmark. We're crossing the power law. We are doing it with good momentum. We are going to look at the returns. Right now, it looks like we are in the bull market. The bull market started. Everything looks exactly like before, right? Compared to 4 years. The only thing is liquidity. And I will leave maybe 5 minutes to talk about liquidity, and then we can have another meeting where we talk only about liquidity. Okay, liquidity is the only question mark. Why don't we have a liquidity? We had all the other bull mark before. What is going on? What is different? Right now, we don't have it. Why you're closing subtitles? Open it. I don't know. I don't see where to turn on off subtitles. You should be able to turn them yourself, right? I don't know how to do that. Maybe I can check next time when I launch the video. Okay. Lionel says, excellent point. I don't know what is that point. What is your price prediction top of this cycle and why? Okay, so this is something that we explained many times, but this was a question from Space Credits. So let's answer that question. And going back, so the main chart to answer that question is this one. So the time we already discussed why the time, right? The time is because everything is cyclic. We think that by the end of the year, and by the way, this is basically like a clock that we have here. One is again one of our indicators, and the indicator shows that is going to happen at the end of next year. And again, remember, it's plus or minus 1 month, right? So it's within 1 month. It was within 1 month. And because it's, so far these cycles have been super regular, they're all aligned, there is no evidence that anything is changing, and I don't want to use hand-waving argument to say, because of this, because of that. These are hand-waving argument, right? Who cares if it is Trump or not Trump, if the administration is favorable or not favorable? Bitcoin is somehow neutral over the long term on these kind of things. And we are talking about the cycles that after the power law is one of the most stable things that we see in Bitcoin behavior. So I don't see any reason, both logically or data-wise, to say that things are different. And so we should see the same cycle happening at the same time with 1 month uncertainty. Okay, so around anything between November to end of the year of 25, this is when it should happen. So that answer when. How big, how tall, it's based on this behavior that we described before of the decay of the bubbles. So I told you there is this exponential decay of the bubble. It's only for data points. If you include even the first bubble, you can, if you want to be coherent, you can exclude it. It still works. It just including the first bubble, that is weird because we say it's an anomaly, but then from a decay point of view, it's not. But maybe it's another clue. If you include, it just improves the statistic. It doesn't change the statistics. It just makes them better. 4 data points is better than 3. But the stats still work with 3. Now you have to be careful because 3 data points, it's not super stereotype of statistics, is all what we have. It's not that it's completely meaningless. You can still do it, and then you can extrapolate if that decay continues. If you take it seriously and say, I want to take seriously everything Bitcoin does. If Bitcoin does something, it means something. If there is a decay that is so precise in a place where I'm not expecting a decay, it needs to be taken seriously. I want to take Bitcoin seriously. Now, the moment that Bitcoin does something else, we also take that seriously and say, okay, maybe it was me, that saw a pattern where the pattern was not, or maybe the pattern just lasted this long and then it was broken. Right now, we have no evidence for that. So I'm taking seriously this decay. Has been shown that if you take the first bubble and then the other 2 bubble, you could have predicted the last bubble within a few $1,000s, right? This is how well it works. People could have predicted this bubble by using the other ones, okay? And so if we do the same thing and we use this decay and we are predicting this top here using basically how big this decay is going to be if you extend that decay. You see how this bubble is smaller than this one, and this one is smaller than this one. All these bubbles are smaller than the previous one, and this change in height can be calculated by the decay. You can extend the decay and say how big the height of this peak will be if this decay continues. And it's going to be about 80%. Remember how this was 1.8, something like that, bigger than the decay. This was something like 5 times. The previous one was 10. And so this one is going to be only 80%. So the way to calculate it, you go there where we are supposed to have a bubble, right? We know when. We calculate what the value for the power law is. It's actually You can calculate it relatively to the support or relatively to the trend. I did it relatively to the trend. So if you look at the trend, then it gives us a certain value. So if you want the details, I can show you the details. So see, I can extend these to basically be parallel to this line. And then I know what the value is over there. It's about $135,000, something like that. That is what the trend during that time is. You say, okay, what is 80% more than that? And it gives you 200,000. This is how we do it. We calculate the value of the price at that time due to the power law alone. And then because there are the bubbles and the bubbles are decaying, we are saying we are expecting this time, not a 3 times change from the trend, not 5 times, not 10 times, is only going to be 80%. And 80% gives you 200,000. You see, it's a very simple, but also very coherent and very scientific way of doing it. Now, is it going to work? We don't know. We will have to test. It did work in the past, right? But it's better that somebody giving you their feelings, making a guess, coming up with some complicated nonsense idea. This is exactly how a scientist will do it, using some coherent, well thought, methodical approach. Now, a scientist probably will also will get a lot of pushback by people saying, well, you're doing it only on 4 points. But there are many situations where that happens. Like, imagine, I'm studying, in particular in astronomy, where there are sometimes very few events. Imagine I only have, I have this star that has been showing these oscillations over, a 5 years period, 6 years period. So we are studying it over the last 50 years. We don't have many of these cycles. We have only few, and we are trying to see if these regularities continue. So and you see maybe the pulse of a flash of light, and every 4 years he makes this big flash of light, and maybe there is like an explosion, that happen on a regular fashion. There are plenty of paper, believe me, in astronomy is because it's very similar to this, very different from what you do on the lab. When you do physics experiment, there are some type of physics where you have your bucket or whatever, your box where you're doing your experiment, and you can do it millions and millions of times, right? You can do it every day, and you collect incredible, crazy statistics. And then there are things like astrophysics, where there are these events that because of the scale involved, time, distances, the stars that have these rare events that are happening once every 5 years. What do you do, right? In the old time, when they were trying to find out the orbit of the planets, they will look at a small section of a comet, path, and that was not even the full path or whatever, and they had to deduce by that little segment of information what will be the future path, right? Sometimes you do that. You take a chunk of information, all what you have, understanding and clarifying to the people that follow you the limitation of what you're doing, that is done on limited data. So, but it's the only scientific way of doing it, based on the reality of what happened. Everything else, it's just hand waving. So, you could make anything goes. And I can make any weird line, any weird prediction. If everything happens as it has happened before, then this we are expecting. And I think it's a relatively conservative estimation. Now, it seems easy to go there, right? Like, we have this amount of time, we need only to go there. If I turn off the log, it looks much more daunting, right? Look at where the other bubbles were and where this bubble needs to be. It looks much more daunting in the linear chart. Okay, we need to go all the way there, right? Are we going there? In 1 year from now,
Now, Leo, the other guy, he's saying we are going there because he has a similar height, because he does a very similar thing. He uses the same decay that I'm describing to predict the height of the next pulse. But this Leo guy says that it's going to happen in April, that is over there. So we have even less amount of time to go over there. Okay, I think it's going to be already hard to arrive there from where we are right now. Okay, so, and for, if you're thinking about 500,000, that is over there, like imagine you need to go over there. Okay, from where we are here, we are going over there. I don't think so. I think it's very, very unlikely. So that answered that question of how I estimate. I wrote an entire article. I will put it in the comments. You can read some of my article. It's an article that discusses this thing. By the way, part of the article talking about models that don't work, there is this guy. I think he's a very popular. I like him actually because he does a lot of TA, but he could have been a good scientist, I think, because he talks about how charts are important. He has this slogan, women lie, men lie, chart don't lie. I think his channel is called Crypto University. And today somebody was asking me about this 5.3 theory. It's not a theory. You will not call that a theory because a theory means something completely different. The power law is a theory. A theory is when you have a full picture of a phenomena where you describe all the different aspects of a phenomena. Like this is why the Bitcoin power law theory is a theory, because it doesn't just tell you about the power law, it tells you also where the power law comes from. It comes from adoption, the Metcalfe. When you put all these pieces of a puzzle together, this is when in science we say it is a theory. But by the way, is the opposite of what people think, that a theory is a guess. It's not a guess. It's a deep understanding of a scientific phenomena. It's one of the highest form of understanding when you have a theory, like the theory of relativity, quantum mechanics theory. These are the highest level of understanding of the evolution theory, of understanding of a phenomena. It's a coherent, self-sufficient theory or description of a phenomenon. And Bitcoin power law theory is a theory because we have why we have a power law, what are the mechanisms behind the power law. We describe a bubble because we say, well, in one end there are no bubbles, in the other we do, and this is why we are there, all these kind of things. So it's a theory. This 5.3 hypothesis, whatever you want to call it, or pattern recognition is actually in my article I discuss it because it's one of the reasons why I wrote my article, because it makes a claim that we already reached the top of a cycle when we were the last ATH was the top of a cycle, when we were about 70,000 or whatever, when we did the ATH, and we will never reach that again, in this cycle. This is what he was saying, that we already reached it. And he had some pseudo math argument, and I explained why it sounded good, but it was not good from a mathematical point of view. And it's already violated because we already gone beyond what he said was the ceiling, and we are already above that. So that hypothesis is gone. And this is how science works, right? You get data and then you say, okay, somebody made this argument and he said that this was going to happen, and it didn't happen because we went above that limit, and we will continue. We will go to 100K. So it doesn't work. Anyway. So Lionel Delamo is asking, what about adoption gains? Does accumulate more during bubbles? Yes. In fact, you can see that the addresses respond to the bubble. They don't respond as hard as the price. The price has this additional FOMO. It responds faster than adoption, but adoption grows faster during the bubbles. And I have these network equations where I describe the power law through these equations that are typical of networks. And you can calculate the strength of the links, because the idea is that addresses are the nodes and price is proportional to the links. And you can show that during the bubble, how strong the links are is changing during the bubbles. So if you allow, you change, if you keep it as a constant, say, okay, this strength doesn't change ever, you get the normal power law. If you allow it to change over time, you get the bubbles. It is really cool because it can be described as a change in the network. The bubbles can be described as a change in the network properties. It's really cool. It's a really cool result. Saxon Smith, that is one of my fans. Thank you so much to be here. He says, ciao, Joe. He never miss one of my live chats. I love him. What is the price target for this bull run? I just said it. Thank you, Hypernova. Thank you, Juni. So generous. Thank you so much. I really appreciate your donation. Sorry, I should have Hypernova say he doesn't read it. Keeps on waffling. Okay, I need to check that term. Sorry if I get focused like this and then I forget to check the chat. I should do more often. 200K is still clear. This is what knowing formation say. Modern day debate says, I think he adapts a bit here and there, but last year he predicted a lead. If I say 200 or 210, it's basically the same thing, right? I mean, what do you expect? It's not going to be to the dollar. It's not going to be to the $1,000. It's going to be plus or minus 10%, even 20%. It's already amazing that we can do this kind of predictions, right, within these ranges. One way, more scientific way of doing it, I did. And I can update it, etc. I did this what are called Monte Carlo. So you are allowing for the stats, and these are real stats from the returns, and you look at what are the typical returns and the typical variability in the returns. That is called the volatility, by the way. And then you can create like alternative paths for this bull run. And you run it like millions of times. And then that gives you a range of possibilities. And the range of possibility, of course, as you go away from the mean, it's going to be less and less likely. But even if you go to almost like the most unlikely scenarios, we get something on the order of 280,000. And this will be the most unlikely scenario, given everything we know, given the volatility stays the same, the type of path that we predict that is this 0.33% per day. So if we go up 0.33% per day and give it some volatility, we go anything between 280 to 150. So that is the range of the craziest possible scenario, one positive and one negative. So at the worst, we should get 150. At the best, we should get 280. Something in that range. Thank you for your work. Churchill says, what do you recommend to start learning about the power laws and how affect our lives? So there is this fantastic book. It's called, I'm going to put it in the comments, but you can look it up. It's called Scale. Scale is the book that I recommend everybody to read. It's fantastic. It doesn't talk about Bitcoin, but it talks about cities, many different other phenomena in life, biology, physics, where power laws are everywhere around us and are very important to understand the universe and even ourselves, physiology, human interactions, wars. I show in one of my exposts, even the time in between wars, it's a power law. It's amazing. They are coming up everywhere. And it's amazing that Bitcoin follows the power law. It tells us a lot of that. This asset is so unique and so interesting and reliable, right? Now, one of the things I'm not talking, and maybe we can dedicate another video on this, once we understand the cycles are going to be there, right? And right now, unless we have some strong evidence that the cycle is not repeating, and we can discuss how we will know that the cycle is not repeating. Okay, it's too deep of a discussion to do it now. Let's have another meeting in a few days, and we can go deeper. And I want to discuss two things. One is, how do we know if we are not following a cycle anymore? And two, why is important to understand this cycle? Besides just, we love a Bitcoin, we want to understand Bitcoin, we go deeper, because a lot of things in life, you don't need to have a reason behind wanting to know, right? Why do we want to know the Big Bang? Right now doesn't have any consequence, right? For direct consequence, but it's fascinating to know where we came from, right? But with Bitcoin, you actually can use these, right? You go from science to technology. This is when you actually use the science for something practical, and you have a technology. And my idea, and then we can discuss deeper all the different possibility of the different things that we do, that if you want, because remember that level of enlightenment, right? All the meme that I was discussing, all the different phases of reaction to the different levels, right? If you want, and you want to spend the time, and you learning, and you go deeper, and you can use these to your advantage. And I know it's a very touchy subject. People react in a very emotional way, because you don't have to. You want to hodl forever. Nobody's attacking you. Nobody's saying you're stupid. Nobody's saying, in fact, it's great. Hodl. We already know the power law is going up. It's a great choice. My suggestion, or my opinion, or my understanding, and something that I will do personally, is that the bubble are there, are part of the history of Bitcoin, and they can be used to multiply your Bitcoins. Now, you have to be careful. You have to be clever in how to use it. And even people like British Odor, it was so funny, because he came up with a video eventually after attacking me and say I'm crazy, this and this other, where he say, oh, you guys should buy some put options, etc. You should protect, sell, even say sell some of your Bitcoin to actually finance these options. Like it was saying exactly what I was saying, because I never say sell all your Bitcoin, have a top, or sell even half of it. I say there are different possibilities. There is, you can use options, you can use you can sell a little bit, you can try to do things with MicroStrategy, with the miner. There are so many different things. It's just a very interesting thing that I was telling you, remember I told you 0.33% per day per 1 year versus 0.1% per day if we stay on the power law. So you have 1 year where we are going 3 times as fast as the power law. Don't you think is a good idea after a certain point to lock some of this gain? So when there be a correction, because the corrections are going to happen. Everybody tells you there will not be a correction. They don't know what they are talking about, because it's part of human nature. It's part of how these assets are working, even with Bitcoin, that there will be a correction. It's unavoidable. It's healthy, actually. It would not be good for Bitcoin if it was not such a correction. When there is a correction, you can use this extra cash that you put on the side, spend it in stupid things, in chocolate bars, on women, or whatever, or men, do it and buy more Bitcoin, So we can discuss these, what are the different possibilities, what are the different strategies, what you want to do. We can have an entire video on that, But I think it's such a crucial aspect of Bitcoin to have these bubbles where we go faster, we have this exponential behavior, that it will be not ideal. Okay, this I can say, it would not be ideal, would not be optimal not to use this information. Now, of course, that depends on your personality, depends where you are, depends how much time you have, stress levels, but saying the opposite, that it's idiotic, to do this, that it's stupid, that you don't want to do it, it's also stupid. It's extremely stupid to say that. For the people that want to do it, and do it consciously, because we are not going to do it in a degen way. We're not going to gamble and open under pair position, under leverage position. No, we are not going to do it. We are going to do it in a very aware, very focused, very open eye type of approach. We are going to monitor everything. We are going to have many different indicators, many different pieces of information that come together to tell us, listen, even if the price continues to go up, this is a good place where to take. It's almost like in a video game where you're like you have one of these places where you save, right? What is the technical term for that, right? One of these land posts where you want to save a game because you want to go to the next phase. This is a good place, because if there is a correction, you will be able to buy more Bitcoin. If there is not a correction, you still can continue because you have most of your assets in Bitcoin anyway. You're not going to sell. Maybe you're not going to use futures. Maybe you're going to do, there are many different things that we can do. And so saying that it's not good to do that is not right either. In fact, I think it's much more wrong, because actually there is a lot of information there that you can use. And it's part of what Bitcoin does. If Bitcoin has these cycles and there is a possibility to multiply your Bitcoin, you can. Just to give you an idea, and then we can finish here, and then we can go deeper next time. We can look at liquidity and all kind of things like that. I think liquidity will not fit here in the discussion anyway. It's better to have a separate discussion. So let me conclude with this. I did a calculation where if you could do this game perfectly, of selling all your Bitcoin, but again, it's not what I say at all to do, but just as, if we had 100% knowledge, of course, right, it will be the only thing that you should do. It will, in that case, it will be stupid, but, it will be a fantasy situation, right? No, believe me, even if we had that perfect knowledge, whatever that means, because there is nothing in life that is perfect knowledge, there will be people that will not act on it, because that is part of human nature. That is also when they say, oh, everybody, plan C was saying this today, everybody will sell at the top, everybody, this is what we are going to do. No, because it doesn't matter how many videos of like this I will do, doesn't matter how much evidence there is that we are on the top and the price is going to crash. Many people will not do it. They will not take action. They will be paralyzed. They will not be able to act. It's part of human nature. Even if we had something close to perfect knowledge, people will not act. But if we had, it would be our only rational choice, right? It will be the only rational choice, because then you could buy back here and you could make a lot of money, right? You could multiply your Bitcoin. But we don't have it. But at the same time, it's not zero knowledge either, right? It has to be somewhere in between. And so, given that it's somewhere in between, there is some level of rational choice of what to do when we reach this peak, if we have all the evidence that we are close to the peak. And we can discuss that next time. How do we know that we are still on the peak, on this cycle? How do we know that it's broken? So there are ways, and we will monitor. And there are ways of dealing with the uncertainty, right? And making rational choices that are good choices, because it can go both directions, right? And it's not going to be a coin toss. It's going to be some level of probability that we are going down, anything between 0 to 100 is going to be somewhere. And then the most rational choice will be to do something, or nothing. Depends on so many other things, like your personality, your character, where you are in life, how much Bitcoin you own, because it's different. It's easy for somebody that has thousands of Bitcoin not to care that there are bubbles. Maybe it's actually an annoyance for them. But for somebody that wants to multiply their Bitcoin, and this is one of a few possibilities because they are rare, right? They're happening every 4 years, etc. It's an opportunity if you do it correctly. It's an opportunity. I was trying to tell you that if you did this correctly, remember, we can simplify and say the power is 6, right, for Bitcoin. The power law is a power of 6. So if you extend this for the next 15 years, right, you go, because basically We are looking for doubling the time that Bitcoin has existed. Remember, if we were only 3 years, let's say we existed only for 3 years, Bitcoin existed only for 3 years, we double these 3 years, and in 6 years, we will go up 65 times, because every time we double the time Bitcoin existed, we go up for 65, because 2 to the 6 is 65. 3 times, imagine we were 3 years, we multiply by 3, 9 years, that will be 720. So in 9 years total, you will have gone 720 up. Can you imagine? This is where the diminishing returns of a power law, that 1 over time effect that I mentioned, that is different from the exponential, comes into place, where now we will have to wait 15 years to double the time of existence of Bitcoin. This is why it takes longer and longer time to go up. But 65 times in 15 years is still amazing, right? Still incredible. And only Bitcoin can give you that kind of returns. Well, if you could do this thing perfectly, where you sold here, bought it back, because we will have, in 15 years from now, we will have basically other 3 of these bubbles, right? If you could do this perfectly, instead of 65, you get 1,200 per. Compare the difference, 1,200 versus 65. It's enormous. Now, nobody's going to do it perfectly, and you should not sell everything, maybe just a portion, or maybe do the equivalent, like with option, etc. But that is just to give you a feeling. So even if it is just a percentage, imagine you are able to execute only, 20% of this, right? So your efficiency in terms of how much of the capital you're involving in this game of using the information from the bubbles, just 20%. Okay, so we are still talking about 240 times versus 65. So it's something to consider, in particular if you want to do it with a portion of your assets. Something that you should be aware. And then you say, listen, I'd rather get 65 and not doing anything and just sit on it, and I maybe just look at the chart once in a while. Okay, it's a great choice. You can, but for the people who want to go to the different memes levels and learn and try to do something different and take some risk, maybe there are some huge rewards at the end of this journey, right? So that is the entire idea. All right. Maybe one more question. Do you think after 15, 20 years, the bubble will no longer exist? I think they will always exist. They go down in size, but they always exist. Okay. All right. So I think we did this video. We managed again to talk for almost 3 hours. In fact, 3 hours, basically. Hopefully, it's a lot of information. We'll try to put some timestamps for the people who want to come back and look at different sections, etc. I will spend some time in adding some stamps. I will have some links about the book. Also, the indicator. So if you're interested in having this indicator and playing with the indicators, you can have all these indicators plus the liquidity indicators. We do it everything through this Discord group that we have. You can join our Discord group. We have about 800 people right now. And through the Patreon program I made a pledge that even if I create 30 indicators, adding new things, we have a macro strategy indicator. I'm going to have a minor indicator. It's going to be always the same amount, maybe slowly adjusted for inflation or whatever it is. But right now it's $20 a month. That is basically like you're getting it for free, because if you go and look at other indicators that people create online and they have services for it, some of them are $100 each, every single one. Right now we have 9 for $20, mostly because it's a service to the community, and all what I'm asking you is just a little appreciation from your side, where we can continue to do this work full time. So consider that. I will have a link for the indicators, how to get the indicators if you're interested. Okay, I'm going to have a video like this soon, maybe in a few days, maybe next week, where we discuss all the different possibilities that we have when we reach the top, and also some more topics. In particular, I want to tell you why we have a bubble in the first place. We have a video. I will have also a link for the video where we go in depth on that, but we can have it as a discussion and go a little bit deeper. Why do we have bubbles in the first place? Okay. All right. Thank you, guys. Thank you so much. This was amazing that you were able to stay even partially for 3 hours with me. I really appreciate it. It goes both ways. I learn from you, like hopefully you learn from me. Thank you so much, guys. Bye.